Deep in the vast expanse of the universe lies a galaxy that defies everything we think we know about the cosmos. NGC 1300, a stunning spiral galaxy located over 65 million light-years away, is not just a beautiful swirl of stars and gas. It's a cosmic enigma, a place where the rules of physics seem to bend and where mysteries lurk in every corner. From vanishing stars to phantom black holes, from unexplained gamma-ray bursts to regions where time itself appears to slow down, NGC 1300 is a treasure trove of the bizarre and the unexplained. In this video, we're going to take you on a journey through 50 of the strangest phenomena ever observed in this galaxy. Each one will challenge your understanding of the universe and leave you questioning what we truly know about the cosmos. So buckle up and prepare to explore the unknown, because by the end of this video, you'll see the universe in a way you never have before. Let's dive into the mysteries of NGC 1300. Now let's turn our attention to the first of these 50 strange phenomena, the enigmatic spiral arms of NGC 1300. At first glance, the galaxy's spiral arms might seem like a familiar sight, resembling the graceful curves we see in other spiral galaxies. But look closer and you'll notice something extraordinary. Unlike most spiral galaxies where the arms flow smoothly outward from the center, the arms of NGC 1300 are unusually tight and sharply defined. They twist and coil in ways that defy the typical patterns we've come to expect. What makes these spiral arms even more puzzling is their formation. In most galaxies, spiral arms are thought to be the result of density waves, ripples that move through the galaxy's disk, compressing gas and dust and triggering star formation. But in NGC 1300, the arms don't follow this conventional model. Instead, they appear to be more rigid, almost as if they're being held in place by some unseen force. Some scientists speculate that the galaxy's unique structure could be the result of a past interaction with another galaxy, a cosmic collision that left its mark on NGC 1300's shape. Others suggest that the galaxy's central bar, a dense, elongated region of stars at its core, might be playing a role in shaping these arms, creating a gravitational influence that twists them into their unusual form. Yet, despite these theories, the true origin of NGC 1300's spiral arms remains a mystery. Why do they look so different from those in other galaxies? What forces are at work to create such a striking and unusual pattern? These questions continue to baffle astronomers, making the spiral arms of NGC 1300 one of the most intriguing puzzles in the cosmos. And as we move deeper into the galaxy's mysteries, this is just the beginning of the strange and unexplained phenomena waiting to be uncovered. Now, shifting our gaze to the heart of NGC 1300, we encounter a mystery that challenges our understanding of galaxies, the missing supermassive black hole. In most large galaxies, including our own Milky Way, a supermassive black hole sits at the center, acting as a gravitational anchor that influences the galaxy's structure and behavior. But NGC 1300 defies this expectation. Despite its size and complexity, astronomers have yet to detect a supermassive black hole at its core. This absence is not just unusual, it's downright perplexing. So, why is this missing black hole such a big deal? For starters, supermassive black holes are thought to play a crucial role in the evolution of galaxies. They regulate star formation, shape the movement of stars and gas, and even influence the growth of the galaxy itself. Without one, NGC 1300 seems to be operating under a different set of rules. Some scientists propose that the galaxy might have a black hole after all, but one that's unusually quiet or hidden from our detection methods. Black holes are typically identified by the intense radiation emitted as they consume matter. But if NGC 1300's black hole isn't actively feeding, it could remain invisible to our telescopes. Another possibility is that the galaxy never formed a supermassive black hole in the first place. This would challenge the widely accepted idea that supermassive black holes are a universal feature of large galaxies. If true, it could mean that NGC 1300 represents a rare exception, offering a unique window into how galaxies can evolve without this central powerhouse. Alternatively, the black hole might have been ejected from the galaxy entirely, perhaps during a violent interaction with another galaxy. Such an event, while rare, could explain the absence while also leaving behind clues about the galaxy's turbulent past. The implications of this missing black hole are profound. If NGC 1300 truly lacks a supermassive black hole, it could force us to rethink our models of galactic formation and evolution. What does this mean for the galaxy's future? How does it maintain its structure without the gravitational influence of a central black hole? These questions remain unanswered, adding another layer of intrigue to this already mysterious galaxy. As we continue our journey through NGC 1300's strange phenomena, the absence of a supermassive black hole stands as a stark reminder of how much we still have to learn about the cosmos. Now, let's turn our attention to something even more elusive: the ghostly dark matter halo that envelops NGC 1300. Unlike the stars, gas, and dust we can see, dark matter is invisible, detectable only through its gravitational effects. This mysterious substance forms a vast, shadowy halo around the galaxy, stretching far beyond its visible boundaries. But what exactly is this dark matter halo, and why is it so crucial to understanding NGC 1300? Dark matter makes up a significant portion of the universe's mass, yet it doesn't emit, absorb, or reflect light, making it impossible to observe directly. Instead, scientists infer its presence by studying how it influences the motion of stars and gas within galaxies. In the case of NGC 1300, the dark matter halo plays a pivotal role in holding the galaxy together. Without it, the galaxy's spiral arms and other structures would likely fly apart due to the immense speeds at which stars and gas are moving. Think of it as an invisible scaffold, providing the gravitational glue that keeps everything in place. But here's where things get even more intriguing. The distribution of dark matter in NGC 1300 is far from uniform. Unlike some galaxies where dark matter is evenly spread, this galaxy's halo appears clumpy and irregular. Some regions are denser, while others are surprisingly sparse. This uneven distribution challenges our current understanding of how dark matter behaves and interacts with visible matter. Scientists are still trying to figure out why this is the case. Could it be the result of past galactic collisions, or does it hint at some unknown property of dark matter itself? Detecting this invisible halo is no small feat. Astronomers rely on a technique called gravitational lensing, where the gravity of the dark matter bends the light from distant objects behind it. By measuring these distortions, they can map the distribution of dark matter in the galaxy. Another method involves studying the rotation curves of stars and gas. If the visible matter alone were responsible for the galaxy's gravity, stars on the outer edges would move slower, but observations show they move much faster, indicating the presence of additional, unseen mass dark matter. The unusual distribution of dark matter in NGC 1300 raises fascinating questions. Why is it so uneven? Could this clumpiness affect the galaxy's evolution over time? And what does it tell us about the nature of dark matter itself? These mysteries remind us that even the invisible forces shaping our universe are far from simple. As we continue to explore NGC 1300, the ghostly dark matter halo stands as a testament to the hidden complexities of the cosmos, urging us to look beyond what we can see and delve deeper into the unknown. Now, let's shift our gaze to one of the most puzzling features of NGC 1300, the mysterious starless regions scattered throughout the galaxy. These vast, dark voids stand in stark contrast to the vibrant swirls of stars and gas that define most of the galaxy. But what could cause such large areas to remain devoid of stars? And what secrets do these empty spaces hold about the galaxy's past? One leading theory suggests that these starless regions might be the remnants of ancient cosmic events. For instance, they could be the aftermath of massive supernova explosions that cleared out gas and dust, leaving behind empty pockets where new stars struggle to form. Alternatively, these regions might have been shaped by powerful galactic winds, driven by the intense radiation from young, hot stars or even the activity of a hidden black hole. These winds could have swept away the raw materials needed for star formation, creating these eerie, starless zones. Another possibility is that these regions are the result of gravitational interactions within the galaxy. NGC 1300's complex structure, with its intricate spiral arms and dynamic core, could have caused certain areas to become gravitationally unstable. Over time, this instability might have disrupted the formation of stars, leaving behind these dark patches. Some scientists even speculate that these regions could be influenced by the galaxy's dark matter halo, which we discussed earlier. The uneven distribution of dark matter might create pockets where star formation is suppressed, adding another layer of mystery to these already enigmatic areas. But why does this matter? These starless regions are more than just empty spaces, they're windows into the galaxy's history. By studying them, astronomers can piece together the events that shaped NGC 1300 over billions of years. For example, if these regions are indeed the result of supernova, they could tell us about the galaxy's past bursts of star formation and the life cycles of its most massive stars. If galactic winds are to blame, they might reveal how energy and matter are distributed throughout the galaxy, influencing its evolution. The absence of stars in these regions also raises intriguing questions about the future of NGC 1300. Could these areas eventually become active again, birthing new stars as conditions change? Or will they remain dark and silent, serving as cosmic graveyards of a bygone era? As we continue to explore these mysterious voids, they remind us that even the emptiest parts of the universe hold clues to its grandest stories. And in the case of NGC 1300, these starless regions are yet another piece of the puzzle, urging us to look deeper and uncover the secrets they've kept hidden for eons. Now, let's turn our attention to another fascinating feature of NGC 1300, its unusual gas distribution. Unlike most spiral galaxies, where gas is spread relatively evenly across the arms and core, NGC 1300's gas appears to be concentrated in irregular clumps and filaments. This uneven distribution has puzzled astronomers for years, as it challenges our understanding of how gas behaves in spiral galaxies. What could be causing this strange pattern, and what does it mean for the galaxy's evolution? One possible explanation lies in the galaxy's dynamic structure. NGC 1300's spiral arms are not just static features, they're regions of intense activity, where gravitational forces and shock waves compress gas, triggering star formation. However, in this galaxy, the process seems to be uneven. Some areas are rich in gas, while others are surprisingly sparse. This irregularity might be due to the galaxy's unique history, such as past interactions with neighboring galaxies or internal processes that have redistributed gas over time. For example, if NGC 1300 experienced a close encounter with another galaxy, the gravitational tug of war could have disrupted its gas distribution, leaving behind these clumps and voids. Another factor could be the role of supermassive black holes or other energetic phenomena. While NGC 1300 doesn't have a detectable supermassive black hole at its center, smaller black holes or active galactic nuclei could still influence the gas. High-energy jets or winds from these sources might push gas around, creating pockets of density and emptiness. Additionally, the galaxy's dark matter halo, which we've discussed earlier, could play a role. If the dark matter is distributed unevenly, it might affect how gas moves and accumulates, leading to the irregular patterns we observe. The impact of this unusual gas distribution is significant, especially when it comes to star formation. In most spiral galaxies, gas is the raw material for new stars, and its even distribution allows for steady star formation across the galaxy. But in NGC 1300, the clumpy gas means that star formation is likely concentrated in specific areas, leading to bursts of activity rather than a steady process. This could explain why some regions of the galaxy are teeming with young, bright stars, while others remain relatively quiet. Over time, this uneven star formation could shape the galaxy's appearance and evolution, creating a unique cosmic landscape. But the story doesn't end there. The irregular gas distribution also affects the galaxy's dynamics. Gas plays a crucial role in maintaining the balance of forces within a galaxy, influencing everything from the rotation of its arms to the stability of its core. In NGC 1300, the clumpy gas could lead to unusual gravitational interactions, causing certain regions to behave unpredictably. For instance, areas with dense gas might experience stronger gravitational pulls, leading to faster star formation or even the birth of massive star clusters. On the other hand, gas-poor regions might become stagnant with little to no new star formation. So, what does this all mean for our understanding of NGC 1300? The galaxy's unusual gas distribution is more than just a curiosity, it's a key piece of the puzzle that helps us understand how galaxies evolve. By studying these patterns, astronomers can gain insights into the forces that shape galaxies, from gravitational interactions to the influence of dark matter. And as we continue to explore NGC 1300, each discovery brings us closer to unraveling the mysteries of this extraordinary galaxy. Next, we'll dive into another intriguing phenomenon, the phantom radio signals that seem to defy explanation. Stay tuned. Now, let's shift our focus to one of the most baffling mysteries of NGC 1300, the phantom radio signals. These strange emissions have left astronomers scratching their heads as they don't match any known cosmic phenomena. Unlike the predictable radio waves we detect from pulsars or quasars, these signals are erratic, appearing and disappearing without warning. What could be causing these mysterious bursts, and what do they tell us about the hidden workings of this galaxy? One theory suggests that these phantom radio signals could be linked to the galaxy's unusual gas distribution. As we've discussed earlier, the clumpy and irregular gas patterns in NGC 1300 create pockets of intense activity. These regions might generate powerful magnetic fields or shock waves, which could produce bursts of radio emissions. However, this explanation doesn't fully account for the signal's unpredictable nature. If the gas were the sole source, we'd expect the emissions to follow a more consistent pattern, but they don't. This inconsistency hints at something far more enigmatic at play. Another possibility is that these signals originate from objects we've yet to discover or fully understand. For instance, they could be the result of exotic cosmic events, such as the collision of neutron stars or the sudden collapse of massive stars. These events can release enormous amounts of energy in the form of radio waves, but they're typically short-lived and rare. The fact that these signals are recurring in NGC 1300 suggests that the galaxy might be home to a unique environment where such events occur more frequently, or that we're witnessing an entirely new phenomenon altogether. Some astronomers have even speculated that these phantom radio signals could be tied to the galaxy's dark matter halo. While dark matter itself doesn't emit light or radio waves, its gravitational influence could indirectly trigger energetic processes. For example, dark matter interactions might create regions of extreme density, leading to the formation of massive objects or the amplification of existing radio sources. This idea is still highly speculative, but it opens up intriguing possibilities for understanding the role of dark matter in shaping cosmic phenomena. The significance of these phantom radio signals extends beyond NGC 1300. If they represent a new type of cosmic event, they could challenge our current understanding of astrophysics. Radio emissions are a key tool for studying the universe, helping us map galaxies, detect black holes, and even search for signs of extraterrestrial life. Discovering a new source of radio waves could revolutionize how we interpret these signals and what they reveal about the cosmos. As we continue to study NGC 1300, these phantom radio signals remain a tantalizing mystery. Are they the result of known processes behaving in unexpected ways, or do they point to something entirely new? Each detection brings us closer to an answer, but for now, they serve as a reminder of how much we still have to learn about the universe. Next, we'll explore another strange phenomenon, the vanishing stars that seem to disappear without a trace. Stay tuned. Now, let's turn our attention to another perplexing mystery in NGC 1300, the vanishing stars. Imagine looking up at the night sky, only to find that some of the stars you once saw are no longer there. This isn't just a hypothetical scenario, it's exactly what astronomers have observed in this galaxy. Stars that were once bright and visible seem to disappear without a trace, leaving behind more questions than answers. What could cause a star to vanish so suddenly? And what does this mean for our understanding of how stars live and die? One leading theory suggests that these vanishing stars might be the result of failed supernova. Normally, when a massive star reaches the end of its life, it explodes in a spectacular supernova, leaving behind a neutron star or a black hole. However, in some cases, the star might collapse directly into a black hole without the explosive finale. This process, known as a direct collapse, would make the star appear to vanish almost instantly, as the black hole would swallow all light and matter, leaving no visible trace. While this theory explains the sudden disappearance, it raises another question. Why would this happen more frequently in NGC 1300 than in other galaxies? Another possibility is that these stars are being obscured by massive clouds of dust and gas. NGC 1300 is known for its irregular gas distribution, which we've discussed earlier. These dense clouds could temporarily block our view of certain stars, making them seem as though they've disappeared. Over time, as the clouds shift or dissipate, the stars might reappear. However, this explanation doesn't fully account for stars that remain missing for extended periods, suggesting that something more permanent might be at play. Some astronomers have even proposed that these vanishing stars could be linked to the galaxy's dark matter halo. Dark matter, while invisible, exerts a powerful gravitational influence. It's possible that interactions between dark matter and ordinary matter could trigger unusual stellar behavior, such as sudden collapses or the formation of exotic objects that don't emit light. While this idea is still speculative, it highlights the potential role of dark matter in shaping the strange phenomena we observe in NGC 1300. The implications of these vanishing stars are profound. If stars can disappear without the usual signs of a supernova, it challenges our understanding of stellar life cycles. Supernovae are crucial for dispersing heavy elements into space, which eventually form new stars, planets, and even life. If stars are bypassing this stage, it could alter our models of galactic evolution and the chemical enrichment of the universe. Additionally, the discovery of such events in NGC 1300 suggests that this galaxy might be a unique laboratory for studying extreme astrophysical processes. As we continue to study these vanishing stars, one thing is clear: NGC 1300 is full of surprises. Each observation brings us closer to unraveling the mysteries of this galaxy, but it also reminds us of how much we still have to learn about the cosmos. Next, we'll delve into another fascinating phenomenon, the evidence of a possible galactic collision that may have shaped NGC 1300 into the enigmatic galaxy we see today. Stay tuned. Now, let's shift our focus to a phenomenon that could explain many of the strange features we've observed in NGC 1300, the possibility of a galactic collision. Imagine two massive galaxies, each containing billions of stars, hurtling toward each other in the vastness of space. When they collide, the result is nothing short of cosmic chaos. Astronomers have uncovered compelling evidence suggesting that NGC 1300 may have experienced such a collision in its distant past, and the aftermath of this event could hold the key to understanding its unique structure and behavior. One of the most striking pieces of evidence lies in the galaxy's spiral arms. While spiral galaxies typically have symmetrical arms that curve gracefully outward, NGC 1300's arms appear distorted and uneven. This irregularity could be the result of gravitational forces from a smaller galaxy passing too close, tugging and twisting the arms out of their natural shape. Over time, these distortions would settle into the unusual patterns we see today, creating a galaxy that stands out from its peers. Another clue comes from the distribution of stars and gas within NGC 1300. In a typical spiral galaxy, stars and gas are spread relatively evenly, but in this galaxy, there are regions where stars are densely packed and others where they are conspicuously absent. This patchy distribution could be a remnant of the collision, as the gravitational forces from the merging galaxies would have stirred up the existing material, causing it to clump together in some areas while leaving others sparse. Additionally, the irregular gas distribution we discussed earlier could also be a lingering effect of this cosmic encounter, as the collision would have disrupted the galaxy's gas clouds, scattering them unevenly across its structure. The collision may also explain the absence of a supermassive black hole at the galaxy's center. In many galaxies, including our own Milky Way, a supermassive black hole resides at the core, exerting a powerful gravitational influence. However, NGC 1300 appears to lack this feature. One theory suggests that during the collision, the black hole from the smaller galaxy could have been ejected entirely, flung out into intergalactic space by the immense forces at play. Alternatively, the black holes from both galaxies might have merged, creating a single, more massive black hole that remains hidden from our observations. The lingering effects of this collision extend beyond the galaxy's physical structure. The event would have triggered a burst of star formation as the collision compressed gas clouds, igniting the birth of new stars. This could explain the presence of unusual star clusters and the rapid star formation rates observed in certain regions of NGC 1300. Over time, these newly formed stars would have aged and evolved, contributing to the galaxy's current mix of young and old stellar populations. Understanding the role of galactic collisions is crucial for piecing together the history of NGC 1300. Such events are not just destructive, they are also creative, reshaping galaxies and driving the evolution of the universe. By studying the remnants of this collision, astronomers can gain insights into how galaxies grow, change, and interact over billions of years. As we continue to explore the mysteries of NGC 1300, the evidence of a past collision reminds us of the dynamic and ever-changing nature of the cosmos. Next, we'll turn our attention to another intriguing phenomenon, the unexplained gamma-ray bursts that have been detected emanating from this galaxy. What could be causing these powerful bursts of energy, and what do they tell us about the hidden forces at work in NGC 1300? Stay tuned to find out. Now, let's dive into one of the most explosive mysteries of NGC 1300, the unexplained gamma-ray bursts that have been detected emanating from this galaxy. Gamma-ray bursts are among the most energetic events in the universe, releasing more energy in a few seconds than our Sun will emit in its entire lifetime. Yet, the bursts observed in NGC 1300 don't fit neatly into the categories we've come to expect. They're shorter, more erratic, and seem to originate from regions of the galaxy where such events shouldn't occur. What could be causing these powerful flashes of energy, and what do they reveal about the hidden forces at work in this enigmatic galaxy? One possibility is that these bursts are linked to the remnants of the galactic collision we discussed earlier. When two galaxies collide, the immense gravitational forces can trigger a cascade of events, including the formation of highly unstable star systems. These systems might produce massive stars that live fast and die young, ending their lives in spectacular supernova or collapsing into black holes. Such cataclysmic events are known to produce gamma-ray bursts, but the bursts in NGC 1300 are unusual because they don't align with the typical patterns seen in other galaxies. Could the collision have created conditions that allow for these unique bursts, or is there something even more exotic at play? Another intriguing theory involves the presence of magnetars, ultra-dense neutron stars with incredibly powerful magnetic fields. Magnetars are capable of producing intense bursts of gamma rays when their magnetic fields undergo sudden rearrangements, a process known as a starquake. If NGC 1300 harbors a population of magnetars, their activity could explain the sporadic and intense gamma-ray emissions. However, magnetars are rare and their bursts are usually more predictable. The irregularity of the bursts in this galaxy suggests that if magnetars are involved, they're behaving in ways we've never seen before. There's also the possibility that these bursts are tied to the galaxy's mysterious dark matter halo. Dark matter, while invisible, exerts a gravitational influence on its surroundings. Some scientists speculate that interactions between dark matter particles could produce bursts of energy, though this remains a highly speculative idea. If true, it would revolutionize our understanding of both dark matter and gamma-ray bursts, opening up entirely new avenues of research. The implications of these unexplained gamma-ray bursts are profound. If they're linked to the galactic collision, they could provide new insights into how such events shape the evolution of galaxies. If they're tied to magnetars or dark matter, they could challenge our current understanding of astrophysics and particle physics. Either way, these bursts are a reminder of how much we still have to learn about the universe. As we continue to unravel the mysteries of NGC 1300, these gamma-ray bursts stand out as one of its most puzzling features. They challenge our assumptions, push the boundaries of our knowledge, and remind us that the cosmos is full of surprises. Next, we'll explore another fascinating aspect of this galaxy, the peculiar star clusters that defy standard classification. What makes these clusters so unique, and what can they tell us about the history of NGC 1300? Stay tuned to find out. Now, shifting our gaze to another captivating feature of NGC 1300, we encounter the peculiar star clusters scattered throughout this galaxy. Unlike the star clusters we observe in most galaxies, these clusters defy standard classification models, presenting astronomers with a fascinating puzzle. What makes these clusters so unusual, and what can they tell us about the history and evolution of NGC 1300? Typically, star clusters are categorized into two main types: open clusters and globular clusters. Open clusters are relatively young, containing a few hundred to a few thousand stars loosely bound together. Globular clusters, on the other hand, are much older, densely packed with hundreds of thousands of stars, and often found in the outer regions of galaxies. However, the star clusters in NGC 1300 don't neatly fit into either category. They exhibit characteristics of both, blending the youthful energy of open clusters with the dense, ancient structures of globular clusters. This hybrid nature challenges our understanding of how star clusters form and evolve. One theory suggests that these peculiar clusters might be the result of the galaxy's turbulent past. As we've discussed earlier, NGC 1300 likely experienced a galactic collision, an event that could have triggered the formation of these unique clusters. When galaxies collide, the immense gravitational forces can compress gas and dust, leading to the rapid formation of new stars. In the chaos of such an event, some clusters might have formed in ways that don't align with the typical patterns we see in more stable galaxies. This could explain why these clusters appear to straddle the line between open and globular clusters. Another possibility is that these clusters are remnants of smaller galaxies that were absorbed by NGC 1300 over time. When a larger galaxy consumes a smaller one, the smaller galaxy's star clusters can be stripped away and incorporated into the larger galaxy. These clusters might retain some of their original characteristics while also being influenced by their new environment, resulting in the unusual features we observe today. This process could create clusters that don't fit neatly into existing classification systems, offering a glimpse into the complex history of galactic interactions. What truly sets these clusters apart is their composition. Some of them contain stars with a wide range of ages, suggesting that star formation within these clusters has occurred over an extended period. This is unusual because most star clusters tend to have stars of similar ages, formed from the same cloud of gas and dust. The presence of mixed-age stars in these clusters hints at a more dynamic and prolonged formation process, possibly influenced by the galaxy's unique conditions. The study of these peculiar star clusters not only sheds light on the history of NGC 1300, but also challenges our broader understanding of stellar evolution. By examining these clusters, astronomers can gain insights into the processes that govern star formation in extreme environments, such as those created by galactic collisions or mergers. These clusters serve as cosmic laboratories, offering a rare opportunity to test and refine our theories about how stars and galaxies evolve. As we continue to explore the mysteries of NGC 1300, these star clusters stand out as a testament to the galaxy's complex and dynamic nature. They remind us that the universe is full of surprises, constantly challenging our assumptions and pushing the boundaries of our knowledge. Next, we'll turn our attention to another enigmatic feature of this galaxy, the invisible barrier that seems to block cosmic rays and particles. What could be creating this mysterious shield, and what does it mean for our understanding of the cosmos? Stay tuned to find out. Now, let's venture into one of the most baffling mysteries of NGC 1300, the invisible barrier. Deep within this galaxy, there exists a region where cosmic rays and particles appear to be mysteriously blocked. This phenomenon has left scientists scratching their heads as it defies our current understanding of how cosmic particles interact with galactic structures. What could be causing this strange obstruction, and what does it reveal about the hidden forces at work in NGC 1300? Cosmic rays are high-energy particles that travel through space at nearly the speed of light. They originate from various sources, including supernovae, black holes, and even distant galaxies. Normally, these particles can pass through most obstacles, including gas clouds and magnetic fields, with little resistance. However, in this particular region of NGC 1300, something is stopping them in their tracks. This invisible barrier acts like a cosmic shield, preventing these particles from penetrating further into the galaxy. One leading theory suggests that this barrier could be the result of an extremely powerful magnetic field. Magnetic fields are known to influence the movement of charged particles, such as cosmic rays. If this region of NGC 1300 harbors a magnetic field far stronger than anything we've observed before, it could potentially deflect or trap these particles, creating the illusion of an invisible wall. Such a magnetic field might be generated by the intense activity near the galaxy's core, where supermassive black holes or other energetic phenomena could be at play. Another possibility is that the barrier is linked to dark matter. Dark matter, which makes up a significant portion of the universe's mass, is invisible and interacts only through gravity. However, some theories propose that dark matter could have other, more subtle interactions with ordinary matter and energy. if this region contains a dense concentration of dark matter, it might be altering the behavior of cosmic rays in ways we don't yet fully understand. This could create a barrier that blocks or redirects these particles, leaving scientists to wonder about the true nature of dark matter. A third theory points to the presence of an unknown cosmic structure or phenomenon. For example, some researchers speculate that this barrier could be the result of a massive shock wave from a past galactic collision. When galaxies collide, the resulting shock waves can compress gas and dust, creating regions of intense pressure and energy. These shock waves might generate conditions that disrupt the flow of cosmic rays, effectively creating a barrier. Alternatively, the barrier could be tied to a yet undiscovered type of cosmic object or force, one that challenges our current understanding of physics. What makes this invisible barrier particularly intriguing is its potential implications for our understanding of the universe. If it is indeed caused by a powerful magnetic field, it could provide new insights into the role of magnetism in shaping galaxies. If dark matter is involved, it might offer clues about how this mysterious substance interacts with the visible universe. And if it's linked to an unknown cosmic phenomenon, it could open the door to entirely new areas of research. As we continue to study this enigmatic barrier, one thing is clear. NGC 1300 is a galaxy full of surprises. Each discovery pushes the boundaries of our knowledge, reminding us that the universe is far more complex and mysterious than we often assume. Next, we'll explore another fascinating feature of this galaxy, the time dilation anomaly, where time itself appears to slow down in certain areas. What could be causing this strange distortion, and what does it mean for our understanding of space and time? Stay tuned to uncover more secrets of NGC 1300. Now, let's turn our attention to one of the most mind-bending mysteries of NGC 1300, the time dilation anomaly. Imagine a place where time itself seems to slow down, where the very fabric of reality behaves in ways that defy our everyday experience. In certain regions of this galaxy, scientists have observed phenomena that suggest time is not flowing at the same rate as it does elsewhere. This strange distortion has sparked intense curiosity and debate as it challenges our fundamental understanding of space and time. To grasp the concept of time dilation, we need to revisit one of the cornerstones of modern physics, Einstein's theory of relativity. According to this theory, time is not a fixed, universal constant. Instead, it can stretch or compress depending on factors like gravity and velocity. For example, time moves slower near massive objects such as black holes because their immense gravitational pull warps the fabric of space-time. Similarly, time slows down for objects moving at speeds close to the speed of light. These effects, though subtle in our daily lives, become more pronounced in extreme cosmic environments. In NGC 1300, the time dilation anomaly appears to occur in specific regions where the laws of physics seem to bend. One possible explanation is the presence of an incredibly dense object, such as a supermassive black hole or a cluster of dark matter, exerting a gravitational influence strong enough to distort time. If such an object exists, it could create pockets where time flows more slowly compared to the rest of the galaxy. This would mean that an observer outside these regions might see events unfolding at a different pace than someone within them. Another intriguing possibility is that the anomaly is linked to the galaxy's unique structure. NGC 1300 is known for its unusual spiral arms and irregular gas distribution, which could create conditions that amplify relativistic effects. For instance, if certain areas of the galaxy are experiencing intense gravitational interactions or high-energy processes, these factors might contribute to the observed time dilation. This would make NGC 1300 a natural laboratory for studying how space-time behaves under extreme conditions. What makes this phenomenon so puzzling is its potential implications for our understanding of the universe. If time dilation in NGC 1300 is caused by a massive object, it could provide new insights into the nature of gravity and the behavior of space-time. On the other hand, if it's tied to the galaxy's structure, it might reveal how cosmic environments can influence the flow of time in unexpected ways. Either scenario challenges our current models and opens up exciting avenues for future research. As we continue to explore this enigmatic galaxy, the time dilation anomaly serves as a reminder of how much we still have to learn about the cosmos. It's a phenomenon that not only stretches our imagination but also pushes the boundaries of science. Next, we'll delve into another captivating mystery of NGC 1300, the galactic echoes, where strange reverberations of light and sound have been detected. What could be causing these cosmic echoes, and what do they tell us about the galaxy's hidden secrets? Stay tuned as we uncover more wonders of this extraordinary galaxy. Now, let's shift our focus to another fascinating mystery within NGC 1300, the galactic echoes. Imagine standing in a vast, empty canyon and shouting into the void, only to hear your voice bounce back moments later. Now picture that same phenomenon happening on a cosmic scale, with light and sound reverberating across the galaxy. This is precisely what scientists have observed in NGC 1300, strange echoes that defy conventional explanations. These echoes are not your typical reflections. Instead, they appear as faint, repeating patterns of light and sound that ripple through the galaxy, lingering long after the initial event that caused them. One theory suggests that these echoes could be the result of massive cosmic collisions or explosions, such as supernovae or the merging of black holes. When such cataclysmic events occur, they release enormous amounts of energy which can travel through space and bounce off dense regions of gas, dust, or even dark matter, creating these ghostly reverberations. Another possibility is that the echoes are linked to the galaxy's unique structure. NGC 1300 is known for its intricate spiral arms and irregular gas distribution, which could act like a cosmic echo chamber. As light and sound waves travel through these regions, they might encounter pockets of material that reflect or scatter them, producing the repeating patterns we observe. This would make NGC 1300 a natural amplifier of cosmic signals, offering us a rare glimpse into the galaxy's hidden dynamics. What makes these echoes particularly intriguing is what they reveal about the galaxy's composition and history. By studying the timing, intensity, and frequency of these reverberations, scientists can map out the distribution of matter within NGC 1300. For instance, if the echoes are more frequent in certain areas, it could indicate the presence of dense clusters of gas or dark matter. Similarly, the duration of the echoes might provide clues about the scale and energy of the events that triggered them. The galactic echoes also raise questions about the nature of space itself. Could these reverberations be evidence of phenomena we have yet to discover, such as exotic forms of matter or energy? Or do they hint at the existence of structures within the galaxy that we cannot yet see? These questions challenge our understanding of the cosmos and highlight the importance of continued exploration. As we piece together the puzzle of NGC 1300, the galactic echoes serve as a reminder of how much we still have to learn. They are not just remnants of past events, but also windows into the galaxy's inner workings. Next, we'll explore another captivating mystery, the unstable magnetic field of NGC 1300. What causes this erratic behavior, and how does it shape the galaxy's destiny? Stay with us as we uncover more secrets of this extraordinary cosmic wonder. Moving deeper into the mysteries of NGC 1300, we now turn our attention to one of its most perplexing features, the unstable magnetic field. Unlike the relatively steady magnetic fields found in many galaxies, the one surrounding NGC 1300 is anything but predictable. It fluctuates wildly, creating a dynamic and chaotic environment that has left scientists scratching their heads. Magnetic fields play a crucial role in shaping a galaxy's structure and behavior. They influence the movement of gas, the formation of stars, and even the trajectories of cosmic rays. In most galaxies, these fields are relatively stable, acting like invisible threads that guide the flow of matter and energy. But in NGC 1300, the magnetic field is anything but stable. It shifts and changes in ways that defy our current understanding of galactic physics. One possible explanation for this erratic behavior lies in the galaxy's turbulent history. NGC 1300 is thought to have undergone significant interactions with other galaxies in the past, including collisions and close encounters. These events could have disrupted its magnetic field, leaving it in a state of constant flux. Imagine a calm lake suddenly stirred by a passing storm. The once smooth surface becomes a chaotic swirl of waves and currents. Similarly, the magnetic field of NGC 1300 may still be recovering from these ancient disturbances, leading to its unpredictable nature. Another factor could be the galaxy's unique composition. NGC 1300 is known for its irregular distribution of gas and dust, as well as its complex spiral arms. These features could create pockets of intense magnetic activity where the field becomes concentrated and unstable. Additionally, the presence of dark matter, which we've discussed earlier, might also play a role. Dark matter interacts with magnetic fields in ways we don't fully understand, and its uneven distribution in NGC 1300 could be contributing to the instability. The consequences of this unstable magnetic field are far-reaching. For one, it could be influencing the rate of star formation in the galaxy. Magnetic fields help regulate the collapse of gas clouds into stars, and a fluctuating field might lead to bursts of star formation followed by periods of inactivity. This could explain why some regions of NGC 1300 appear to be teeming with young stars, while others are eerily quiet. Moreover, the erratic magnetic field could be affecting the galaxy's ability to retain its gas. Magnetic fields help hold gas clouds together, preventing them from being blown away by stellar winds or other forces. In NGC 1300, the unstable field might be allowing gas to escape more easily, which could have long-term implications for the galaxy's evolution. Over time, this loss of gas could slow down star formation and alter the galaxy's structure. As we continue to study NGC 1300, the unstable magnetic field remains one of its most intriguing mysteries. It challenges our understanding of how galaxies evolve and interact with their surroundings. What causes these dramatic fluctuations? Could they be a sign of hidden processes at work within the galaxy? And what does this mean for the future of NGC 1300? These are questions that keep astronomers on the edge of their seats. Next, we'll explore another captivating feature of this galaxy, the phantom nebulae. These ghostly clouds of gas and dust appear and disappear unpredictably, adding yet another layer of mystery to NGC 1300. Stay with us as we uncover more secrets of this cosmic enigma. Now, let's turn our attention to one of the most ghostly and enigmatic features of NGC 1300, the phantom nebulae. These mysterious clouds of gas and dust seem to defy the rules of the cosmos, appearing and vanishing without warning. Unlike the more permanent nebulae we often observe in other galaxies, these phantom structures are fleeting, leaving astronomers puzzled about their origins and behavior. Nebulae are typically vast regions of gas and dust where stars are born, glowing brightly as they reflect or emit light. But in NGC 1300, some nebulae behave in ways that challenge our understanding. They flicker in and out of existence, sometimes visible for years before disappearing entirely, only to reappear in a different location or form. This transient nature has led scientists to dub them phantom nebulae, as they seem to haunt the galaxy like cosmic ghosts. One leading theory suggests that these nebulae might be influenced by the galaxy's unstable magnetic field, which we discussed earlier. the erratic magnetic environment could cause pockets of gas and dust to collapse or disperse rapidly, creating the illusion of nebulae appearing and disappearing. Imagine a flickering light bulb. Sometimes it shines brightly, and other times it fades into darkness. Similarly, the phantom nebulae might be responding to the chaotic magnetic forces at play in NGC 1300. Another possibility is that these nebulae are being shaped by intense radiation from nearby stars or black holes. High-energy radiation can ionize gas, causing it to glow brightly before dissipating. In regions where stars are forming or dying at an accelerated rate, this process could create temporary nebulae that vanish once the radiation source diminishes. It's like a firework lighting up the night sky, brilliant for a moment, but gone just as quickly. The presence of dark matter might also play a role. Dark matter's gravitational influence could be causing gas clouds to clump together or break apart unpredictably, leading to the formation and dissolution of these nebulae. While we can't see dark matter directly, its effects on visible matter like gas and dust could explain why these structures are so transient. The phantom nebulae of NGC 1300 are more than just a cosmic curiosity. They offer valuable insights into the galaxy's dynamic environment. Their unpredictable behavior could be a sign of hidden processes at work, from turbulent magnetic fields to intense radiation bursts. By studying these ghostly structures, astronomers hope to uncover clues about the forces shaping NGC 1300 and, by extension, other galaxies with similar mysteries. As we continue our journey through this fascinating galaxy, the phantom nebulae remind us that the universe is full of surprises. What causes these nebulae to flicker in and out of existence? Could they be a window into deeper, unseen processes within the galaxy? And what other secrets might they reveal about the life and death of stars? These questions drive astronomers to keep exploring, pushing the boundaries of our understanding. Next, we'll delve into another captivating feature of NGC 1300, the galactic shadows. These dark patches block light from behind them, creating mysterious voids that challenge our understanding of the galaxy's structure. Stay with us as we uncover more of the secrets hidden within this cosmic enigma. Now, let's shift our gaze to another striking mystery within NGC 1300, the galactic shadows. These dark patches scattered across the galaxy act like cosmic curtains, blocking light from the stars and structures behind them. Unlike the usual dust clouds that dim light, these shadows are far more enigmatic, raising questions about their origins and what lies within them. Galactic shadows are not just ordinary dark regions. They are vast, dense areas that seem to absorb or deflect light entirely, creating voids that stand out against the galaxy's luminous backdrop. Imagine standing in front of a bright window, only to see a massive silhouette blocking the view. That's what these shadows do on a galactic scale, obscuring entire sections of NGC 1300 from our telescopes. One possible explanation for these shadows lies in the presence of unusually dense dust clouds. In some regions of the galaxy, dust particles may clump together in such high concentrations that they prevent light from passing through. These clouds could be remnants of ancient star-forming regions where gas and dust once coalesced to create stars but now linger as dark, impenetrable barriers. Think of it as a thick fog that refuses to let sunlight through, only on a much grander scale. Another intriguing theory involves the role of dark matter. While dark matter itself doesn't emit or absorb light, its gravitational influence could be shaping these shadows. Massive concentrations of dark matter might be pulling gas and dust into dense clusters, creating regions so thick that light cannot escape. It's like a cosmic blackout where the invisible hand of dark matter orchestrates the formation of these mysterious voids. There's also the possibility that these shadows are caused by massive objects we can't yet detect. For instance, rogue planets, black holes, or even undiscovered celestial bodies could be lurking within these dark patches, blocking light as they pass in front of distant stars. These objects, though invisible to our current instruments, could be casting shadows that stretch across the galaxy, leaving us to wonder what lies hidden in the darkness. The galactic shadows of NGC 1300 are more than just dark spots, they are windows into the galaxy's hidden dynamics. By studying them, astronomers hope to uncover clues about the distribution of matter, the behavior of dark matter, and the processes that shape the galaxy's structure. Each shadow tells a story, one that challenges our understanding of how galaxies evolve and what lies within their depths. As we move forward, these shadows remind us that even in the brightest corners of the universe, darkness holds its own secrets. What could be lurking within these massive voids? Are they the result of natural processes, or do they hint at something more extraordinary? The answers may lie just beyond the edge of our current knowledge, waiting to be discovered. Next, we'll explore another fascinating feature of NGC 1300, the unusual pulsars that emit signals at irregular intervals. These cosmic lighthouses defy our expectations, and their behavior could hold the key to understanding even more about this mysterious galaxy. Stay with us as we continue to unravel the secrets of NGC 1300. Now, let's turn our attention to another cosmic oddity within NGC 1300, the unusual pulsars that defy our expectations. Pulsars, often referred to as cosmic lighthouses, are typically known for their precise, rhythmic signals. But in this galaxy, some pulsars are breaking the rules, emitting signals at irregular intervals that leave astronomers scratching their heads. Pulsars are the remnants of massive stars that have exploded in supernova, leaving behind incredibly dense neutron stars. These neutron stars spin rapidly, emitting beams of radiation from their magnetic poles. When these beams sweep past Earth, we detect them as regular pulses of light or radio waves. It's like a cosmic metronome ticking with remarkable consistency. However, the pulsars in NGC 1300 are anything but consistent. One possible explanation for this erratic behavior lies in the environment surrounding these pulsars. In NGC 1300, the distribution of gas and dust is highly irregular, which could interfere with the pulsar's emissions. Imagine trying to shine a flashlight through a thick, swirling fog. The light would flicker and dim unpredictably. Similarly, the pulsar's signals might be distorted as they pass through the galaxy's chaotic interstellar medium. Another theory suggests that these pulsars might be interacting with unseen companions, such as planets or other stars. Gravitational tugs from nearby objects could disrupt the pulsar's rotation, causing their signals to vary in timing and intensity. It's like a spinning top being nudged by an invisible hand, wobbling as it tries to maintain its rhythm. These interactions could be creating the irregular patterns we observe. There's also the possibility that these pulsars are undergoing dramatic changes in their internal structure. Neutron stars are incredibly dense, with matter packed so tightly that a single teaspoon would weigh billions of tons. If the crust of a neutron star were to crack or shift, it could alter the star's rotation and magnetic field, leading to irregular emissions. Think of it as a clockwork mechanism suddenly jamming, throwing off its precise timing. The unusual pulsars of NGC 1300 challenge our understanding of these cosmic objects. While most pulsars serve as reliable timekeepers, these outliers remind us that the universe is full of surprises. By studying their erratic behavior, astronomers hope to uncover new insights into the life cycles of neutron stars and the dynamic processes that shape galaxies. As we continue our journey through NGC 1300, these pulsars serve as a reminder that even the most predictable phenomena can take unexpected turns. What other secrets might these cosmic lighthouses reveal? The answers could reshape our understanding of the universe itself. Next, we'll delve into the mysterious dust clouds that obscure large portions of NGC 1300, hiding some of the galaxy's most intriguing features. Stay with us as we uncover more of the galaxy's hidden wonders. Now, let's shift our focus to one of the most enigmatic features of NGC 1300, the mysterious dust clouds that cloak vast regions of this galaxy. These dense clouds, composed of tiny particles of dust and gas, act like a cosmic veil, hiding some of the galaxy's most fascinating structures from view. But what exactly are these clouds made of, and how did they come to be? The dust clouds in NGC 1300 are primarily made up of microscopic grains of carbon, silicon, and other elements, mixed with hydrogen and helium gas. These particles are so small that they're often no larger than a fraction of a millimeter, yet they accumulate in such vast quantities that they can block out the light from stars and other celestial objects behind them. It's like trying to peer through a dense fog. What lies beyond remains shrouded in mystery. One of the most intriguing aspects of these dust clouds is their origin. Scientists believe they may have formed from the remnants of ancient stars that exploded in supernova. When a massive star reaches the end of its life, it expels its outer layers into space, scattering dust and gas across the galaxy. Over time, these materials clump together, forming the dense clouds we see today. It's a cosmic recycling process where the death of one star gives birth to the building blocks of future stars and planets. Another possibility is that these dust clouds are the result of galactic collisions. When two galaxies collide, the immense gravitational forces can compress gas and dust, triggering the formation of new clouds. NGC 1300's turbulent history, marked by past interactions with other galaxies, could explain why its dust clouds are so prominent. These collisions not only shape the galaxy's structure, but also enrich its interstellar medium with the raw materials needed for star formation. Despite their obscuring nature, these dust clouds play a crucial role in the life cycle of galaxies. They serve as nurseries for new stars, providing the raw materials needed for stellar birth. Within the dense cores of these clouds, gravity pulls gas and dust together, eventually forming protostars. Over millions of years, these protostars ignite, lighting up the galaxy and dispersing the surrounding dust. It's a delicate balance between creation and concealment, where the very clouds that hide the galaxy's secrets also fuel its future. Studying these dust clouds is no easy task. Their opacity makes it difficult for astronomers to observe what lies behind them using visible light. However, by using infrared and radio telescopes, scientists can peer through the dust, revealing the hidden structures within. These observations have uncovered star-forming regions, young stellar clusters, and even evidence of black holes lurking in the shadows. Each discovery brings us closer to understanding the complex interplay between dust, gas, and stars in NGC 1300. The mysterious dust clouds of NGC 1300 remind us that even the most seemingly mundane features of the universe hold profound secrets. They challenge us to look beyond what's visible and explore the hidden depths of the cosmos. As we continue our journey through this galaxy, these clouds serve as a testament to the beauty and complexity of the universe, inviting us to uncover the stories they conceal. Next, we'll explore the swirling region in NGC 1300 that resembles a cosmic whirlpool, a phenomenon that defies explanation and captivates the imagination. Stay tuned as we dive deeper into the galaxy's wonders. Now, let's turn our attention to a mesmerizing feature of NGC 1300, a swirling region that resembles a cosmic whirlpool. This breathtaking phenomenon, with its spiraling arms of gas and dust, looks as though it's been plucked straight from the pages of a science fiction novel. But what exactly is this galactic whirlpool, and what secrets does it hold about the forces shaping this galaxy? At the heart of this whirlpool lies a region of intense gravitational activity. The swirling motion is driven by the interplay of gravity, gas, and magnetic fields, creating a dynamic and ever-changing structure. Unlike the orderly spiral arms of the galaxy, this whirlpool is chaotic, with streams of gas and dust spiraling inward toward a central point. It's as if the galaxy itself is caught in a cosmic dance, with matter being pulled into a vortex of creation and destruction. One theory suggests that this whirlpool could be the result of a massive inflow of gas from the outer regions of the galaxy. As gas streams inward, it begins to rotate faster due to the conservation of angular momentum, much like water spiraling down a drain. This process can trigger the formation of new stars as the compressed gas reaches critical densities. The whirlpool, then, becomes a stellar nursery where the raw materials of the universe are forged into the building blocks of stars and planets. Another possibility is that the whirlpool is the aftermath of a galactic collision. When two galaxies interact, their gravitational forces can distort their shapes, creating swirling patterns of gas and dust. These interactions can funnel material toward the center of the galaxy, forming structures like the whirlpool we see in NGC 1300. Such events not only reshape the galaxy but also inject it with fresh gas, reigniting star formation and altering its evolutionary path. The significance of this whirlpool extends beyond its stunning appearance. It provides astronomers with a unique opportunity to study the processes that drive galactic evolution. By observing the motion of gas and dust within the whirlpool, scientists can gain insights into how galaxies accumulate and redistribute their material. These observations help us understand the life cycle of galaxies, from their birth to their eventual transformation. Moreover, the whirlpool serves as a reminder of the dynamic and ever-changing nature of the universe. It challenges our perception of galaxies as static entities, revealing them instead as vibrant, evolving systems. The forces at play within this whirlpool, gravity, rotation, and magnetic fields, are the same forces that shape the cosmos on a grand scale. By studying this phenomenon, we gain a deeper appreciation for the intricate processes that govern the universe. As we continue our exploration of NGC 1300, the galactic whirlpool stands as a testament to the beauty and complexity of the cosmos. It invites us to ponder the forces that shape our universe and the mysteries that lie within its swirling depths. Next, we'll delve into the phantom gravity wells of NGC 1300, where gravity itself seems to defy the rules. Stay with us as we uncover more of this galaxy's astonishing secrets. Now, let's shift our focus to one of the most baffling mysteries in NGC 1300 phantom gravity wells. These are regions where gravity appears to act in ways that defy our current understanding of physics. Imagine a place where the rules of gravity as we know them seem to bend or even break. What could cause such strange behavior, and what does it mean for our understanding of the universe? Phantom gravity wells are areas where the gravitational pull is either unusually strong or unexpectedly weak, creating anomalies that challenge the laws of physics. In some cases, objects near these wells experience forces that shouldn't exist according to our current models. For instance, stars or gas clouds might accelerate or decelerate without any visible cause, as if an invisible hand is tugging at them. These phenomena are not just quirks of nature, they could hold the key to unlocking new insights into the fundamental forces that govern the cosmos. One possible explanation for these gravity wells lies in the presence of dark matter. Dark matter, which makes up a significant portion of the universe's mass, doesn't interact with light, making it invisible to our telescopes. However, its gravitational effects are undeniable. In NGC 1300, dark matter could be clumped in unusual ways, creating pockets of intense gravitational influence. These clumps might distort the fabric of space-time, leading to the strange gravitational effects we observe. If this is the case, studying these wells could help us map the distribution of dark matter and better understand its role in shaping galaxies. Another intriguing possibility is that these gravity wells are the result of exotic objects, such as primordial black holes or massive compact halo objects known as macho. These objects, if they exist, could exert gravitational forces far beyond what their size suggests. Their presence in NGC 1300 might explain why gravity behaves so unpredictably in certain areas. Detecting and studying these objects could provide clues about the early universe and the formation of galaxies. The implications of phantom gravity wells extend far beyond NGC 1300. If gravity can behave in ways that contradict our current theories, it could mean that our understanding of physics is incomplete. This opens the door to new theories, such as modifications to Einstein's theory of general relativity or the existence of additional dimensions. Each anomaly we discover in these gravity wells brings us closer to uncovering the deeper truths of the universe. As we continue to explore NGC 1300, these phantom gravity wells remind us that the cosmos is full of surprises. They challenge us to rethink what we know and inspire us to ask new questions. Next, we'll turn our attention to an unseen energy source within the galaxy, one that powers some of its most extraordinary phenomena. Stay with us as we uncover more of the galaxy's hidden wonders. Now, let's venture into another enigma within NGC 1300, an unseen energy source that fuels some of the galaxy's most extraordinary phenomena. This mysterious power source, invisible to our instruments yet undeniably present, has left scientists scratching their heads. What could be generating such immense energy, and how does it influence the galaxy's behavior? The unseen energy source appears to be at the heart of several unusual activities in NGC 1300. From sudden bursts of radiation to the acceleration of cosmic particles, this energy seems to drive events that defy conventional explanations. Unlike typical energy sources such as stars or black holes, this one leaves no visible trace, making it all the more perplexing. One leading theory suggests that this energy could be linked to dark energy, the mysterious force believed to be responsible for the accelerated expansion of the universe. In NGC 1300, dark energy might be concentrated in specific regions, creating localized effects that manifest as this unseen power source. If true, this would provide a rare opportunity to study dark energy up close, offering insights into its nature and behavior. Another possibility is that the energy source is tied to an exotic form of matter or a previously unknown cosmic phenomenon. For instance, some scientists speculate that it could be the result of quantum fluctuations or interactions between dimensions beyond our current understanding. These interactions might release energy in ways that are entirely new to us, challenging our existing models of physics. There's also the intriguing idea that this energy source could be the remnant of a long-forgotten cosmic event, such as the collision of two galaxies or the explosive death of a massive star. Such events could leave behind pockets of energy that continue to influence the galaxy for billions of years. If this is the case, studying this energy source could provide a window into the galaxy's ancient past. The implications of this unseen energy source are profound. If it represents a new form of energy or a previously unknown cosmic process, it could revolutionize our understanding of the universe. It might even hold the key to unlocking technologies or insights that we can't yet imagine. As we continue to explore NGC 1300, this unseen energy source serves as a reminder of how much we still have to learn about the cosmos. It challenges us to think beyond the boundaries of current science and inspires us to seek answers to questions we haven't even thought to ask yet. Next, we'll delve into another fascinating mystery, the galactic mirage, a region where light itself seems to play tricks on us. Stay tuned as we uncover more of the galaxy's hidden secrets. Now, let's turn our attention to a phenomenon that seems to defy the very nature of light itself, the galactic mirage. In a specific region of NGC 1300, light behaves in ways that challenge our understanding of physics, creating effects that resemble the mirages we sometimes see on Earth. This cosmic illusion has captivated astronomers and sparked a wave of curiosity about what could be causing such a bizarre distortion. The galactic mirage occurs in an area where light from distant stars and galaxies appears to bend, stretch, or even multiply. Imagine looking through a cosmic funhouse mirror where the images you see are warped and fragmented. This distortion isn't just a visual trick, it's a real effect caused by the intense gravitational forces at play in this region. At the heart of this phenomenon lies a concept known as gravitational lensing. When massive objects like clusters of galaxies or dark matter lie between us and a distant light source, their gravity can bend the path of light, much like a magnifying glass bends sunlight. In NGC 1300, this effect is amplified, creating multiple images of the same object or stretching light into strange, elongated shapes. But what makes this galactic mirage so unique is the scale and complexity of the distortion. Unlike typical gravitational lensing, which often produces clear, predictable patterns, the mirage in NGC 1300 appears chaotic and unpredictable. Some scientists believe this could be due to an uneven distribution of dark matter in the region, creating pockets of intense gravity that warp light in unusual ways. Another possibility is that the mirage is caused by a combination of factors, such as the presence of massive black holes or the remnants of ancient galactic collisions. These events could have left behind a tangled web of gravitational fields, each contributing to the overall distortion. The result is a cosmic kaleidoscope that continues to baffle researchers. The implications of this phenomenon are profound. By studying the galactic mirage, scientists hope to gain new insights into the distribution of dark matter and the behavior of gravity on a cosmic scale. It could also help us better understand the structure of NGC 1300 itself, revealing hidden details about its history and evolution. As we explore this strange and mesmerizing phenomenon, it's a reminder of how much we still have to learn about the universe. The galactic mirage challenges our perceptions and invites us to question what we think we know about light, gravity, and the very fabric of space. Next, we'll uncover another mystery: phantom supernova, stars that explode and leave no trace. Stay with us as we continue our journey through the wonders of NGC 1300. Now, let's shift our focus to a phenomenon that defies one of the most dramatic events in the universe: the phantom supernova. In NGC 1300, astronomers have observed something truly baffling: stars that appear to explode in brilliant supernova, only to vanish without leaving any trace behind. This mysterious behavior challenges everything we know about stellar life cycles and raises questions about what could be happening in this enigmatic galaxy. Supernovae are typically some of the most energetic events in the cosmos. When a massive star reaches the end of its life, it explodes in a spectacular burst of light and energy, often leaving behind a glowing remnant like a neutron star or a black hole. These remnants serve as cosmic fingerprints, allowing scientists to study the aftermath of these colossal explosions. But in NGC 1300, something strange is happening. Stars are exploding and then nothing. No remnants, no traces, just silence. This absence of evidence is what makes phantom supernova so puzzling. Normally, the aftermath of a supernova is visible for thousands or even millions of years, providing a wealth of information about the star's composition, the explosion's mechanics, and the surrounding environment. But in these cases, it's as if the supernova never happened. The light fades and the star simply disappears from view, leaving astronomers scratching their heads. One theory suggests that these phantom supernovae could be the result of a rare type of stellar explosion known as a failed supernova. In this scenario, a massive star collapses directly into a black hole without the usual explosive display. Instead of a bright flash, the star's core implodes, swallowing itself and leaving no visible trace. While this phenomenon has been theorized, it's incredibly rare and difficult to observe, making NGC 1300 a potential goldmine for studying these elusive events. Another possibility is that the remnants of these supernovae are being obscured by dense clouds of dust and gas within the galaxy. NGC 1300 is known for its irregular distribution of interstellar material, which could hide the glowing remnants from our view. If this is the case, advanced telescopes and new observational techniques might one day reveal the hidden secrets of these phantom explosions. The implications of phantom supernova are profound. If stars can explode and vanish without a trace, it could reshape our understanding of stellar evolution and the life cycles of massive stars. It also raises questions about the role of black holes in these processes and how they interact with their surroundings. By studying these mysterious events, scientists hope to uncover new insights into the forces that shape galaxies like NGC 1300. As we continue to explore the strange and wondrous phenomena within this galaxy, the phantom supernovas stand out as a reminder of how much we still have to learn. These vanishing acts challenge our assumptions and invite us to rethink what we know about the universe's most dramatic events. Next, we'll delve into another mystery, the unstable quasar, a cosmic beacon that flickers unpredictably. Stay with us as we uncover more of the secrets hidden within NGC 1300. Now, let's turn our attention to another cosmic enigma within NGC 1300, the unstable quasar. Quasars are among the brightest objects in the universe, powered by supermassive black holes at the centers of galaxies. They emit immense amounts of energy, lighting up the cosmos like beacons. But in NGC 1300, there's a quasar that doesn't follow the rules. Instead of shining steadily, its brightness fluctuates wildly and unpredictably, leaving scientists puzzled about what could be causing such erratic behavior. Quasars typically glow with a consistent intensity, fueled by the superheated material swirling around their central black holes. This material forms an accretion disk, a glowing ring of gas and dust that emits light as it spirals inward. The brightness of a quasar usually depends on the amount of material being consumed by the black hole, which tends to remain relatively stable over time. But the quasar in NGC 1300 is anything but stable. Its brightness can spike or drop dramatically in a matter of days or even hours, defying the usual patterns observed in these cosmic powerhouses. One possible explanation for this instability lies in the chaotic environment surrounding the quasar. If the accretion disk is being disrupted by external forces, such as collisions with other galaxies or the gravitational pull of nearby objects, it could cause irregular feeding patterns for the black hole. When the flow of material into the black hole becomes erratic, the quasar's brightness would naturally fluctuate as well. This scenario suggests that NGC 1300's quasar might be experiencing a turbulent cosmic neighborhood, one that's constantly reshaping its behavior. Another theory points to the possibility of magnetic fields playing a role. Quasars are known to have incredibly strong magnetic fields, which can influence how material moves within the accretion disk. If these fields are unusually unstable or interacting with other magnetic forces in the galaxy, they could cause sudden changes in the quasar's brightness. This would make the quasar a unique laboratory for studying the complex interplay between magnetic fields and black hole activity. The implications of an unstable quasar are significant. If the brightness fluctuations are tied to the black hole's feeding habits, it could provide new insights into how supermassive black holes grow and evolve. It might also reveal how external factors like galactic collisions or magnetic fields can influence these cosmic giants. For astronomers, this quasar offers a rare opportunity to study the dynamic processes that govern some of the most extreme environments in the universe. As we continue to unravel the mysteries of NGC 1300, the unstable quasar stands as a testament to the galaxy's complexity. Its unpredictable behavior challenges our understanding of quasars and invites us to explore the forces that shape their existence. Next, we'll dive into another fascinating phenomenon, the galactic ripples, mysterious waves in the fabric of space-time that ripple through this enigmatic galaxy. Stay tuned as we uncover more of the secrets hidden within NGC 1300. Now, let's shift our focus to another extraordinary feature of NGC 1300, the galactic ripples. These ripples are not like the waves you see on water, but rather disturbances in the very fabric of space-time itself. Imagine space-time as a vast, invisible sheet, and these ripples as tiny wrinkles or vibrations moving through it. In NGC 1300, astronomers have detected these ripples, and their presence has sparked a wave of curiosity and debate within the scientific community. So, what could be causing these ripples? One leading theory suggests they are the result of massive cosmic events, such as the collision of two supermassive black holes. When these colossal objects merge, they release an enormous amount of energy in the form of gravitational waves, which ripple through space-time like ripples on a pond. These waves can travel across vast distances, carrying information about the events that created them. In the case of NGC 1300, the ripples could be remnants of a past collision, echoing through the galaxy and leaving behind a faint but detectable signature. Another possibility is that these ripples are caused by the movement of dark matter. Dark matter, which makes up a significant portion of the universe's mass, doesn't interact with light, making it invisible to traditional telescopes. However, its gravitational influence can warp space-time, creating ripples that ripple outward. If dark matter in NGC 1300 is clumping or moving in unusual ways, it could generate these mysterious disturbances. This would provide a rare glimpse into the behavior of dark matter, a substance that remains one of the greatest mysteries in modern astrophysics. The significance of these ripples goes beyond their origin. Detecting and studying them could help us better understand the fundamental nature of space-time itself. According to Einstein's theory of general relativity, massive objects can bend and stretch space-time, and these ripples are a direct manifestation of that phenomenon. By analyzing the ripples in NGC 1300, scientists can test and refine our understanding of gravity, space, and time, potentially uncovering new insights into how the universe works. Moreover, these ripples could serve as cosmic messengers, carrying information about events that occurred billions of years ago. They might reveal details about the early universe, the formation of galaxies, or even the nature of dark energy, the mysterious force driving the accelerated expansion of the universe. Each ripple is like a whisper from the distant past, offering clues about the history and evolution of the cosmos. As we continue to explore NGC 1300, the galactic ripples remind us of the dynamic and ever-changing nature of the universe. They challenge us to think beyond what we can see and to consider the invisible forces shaping the cosmos. Next, we'll delve into another intriguing phenomenon, the phantom planets, mysterious worlds that appear and vanish within this enigmatic galaxy. Stay tuned as we uncover more of the secrets hidden within NGC 1300. Now, let's turn our attention to another baffling mystery within NGC 1300, the phantom planets. These rogue worlds, which seem to appear and vanish without warning, have left astronomers scratching their heads. Unlike the planets in our own solar system, which orbit a star in predictable paths, these phantom planets drift freely through the galaxy, untethered to any stellar anchor. Their fleeting nature makes them incredibly difficult to study, but their existence raises fascinating questions about how such worlds come to be and what their presence means for our understanding of galactic dynamics. One possible explanation for these phantom planets is that they were once part of a planetary system, but were ejected due to gravitational interactions. Imagine a young star system where planets are still forming and jostling for position. If a massive object like a passing star or another planet comes too close, it could disrupt the delicate balance, flinging one or more planets out into the void. These ejected worlds would then wander through the galaxy, becoming rogue planets. In the case of NGC 1300, the galaxy's turbulent history, including past collisions and gravitational disturbances, could have created the perfect conditions for such events to occur. Another intriguing possibility is that these phantom planets formed on their own without ever being part of a star system. In the cold, dark regions of space, clouds of gas and dust can collapse under their own gravity, forming objects known as sub-brown dwarfs or free-floating planets. These worlds might never ignite into stars but could still grow large enough to resemble planets. If NGC 1300 has regions rich in such material, it could explain the presence of these mysterious wandering worlds. The transient nature of these phantom planets adds another layer of mystery. Some scientists speculate that they might not actually vanish but instead become temporarily invisible. For instance, a rogue planet could pass behind a dense cloud of dust or gas, blocking our view of it. Alternatively, its surface might undergo sudden changes, such as volcanic activity or atmospheric shifts, altering its brightness and making it harder to detect. These factors could create the illusion that the planet has disappeared, only to reappear later when conditions change. The study of phantom planets in NGC 1300 could provide valuable insights into the processes that shape galaxies. Rogue planets, though elusive, might be more common than we think, and their presence could influence the distribution of matter and the formation of new star systems. By understanding their origins and behavior, we could gain a deeper appreciation for the complex and dynamic nature of the universe. As we continue to unravel the secrets of NGC 1300, the phantom planets remind us that there is still so much to discover. These wandering worlds challenge our assumptions and invite us to explore the unknown. Next, we'll dive into another enigmatic phenomenon, the unusual radiation patterns emanating from this galaxy. Stay with us as we uncover more of the cosmic mysteries hidden within NGC 1300. Now, shifting our gaze to another cosmic puzzle, let's explore the unusual radiation patterns emanating from NGC 1300. These patterns, unlike anything observed in most galaxies, have sparked intense curiosity among scientists. The radiation doesn't align with typical sources like stars, black holes, or supernovae, leaving researchers to wonder what could be producing such enigmatic signals. One leading theory suggests that these radiation patterns might originate from highly energetic processes occurring in the galaxy's core. For instance, the interaction between intense magnetic fields and charged particles could generate bursts of radiation that ripple outward. Another possibility is the presence of exotic objects such as magnetized neutron stars with incredibly powerful magnetic fields. These objects are known to emit intense radiation, and if NGC 1300 harbors such a magnetar, it could explain the unusual signals. Alternatively, the radiation might be linked to the galaxy's turbulent past. If NGC 1300 experienced a collision or merger with another galaxy, the resulting shockwaves could have triggered massive bursts of energy, leaving behind lingering radiation patterns. This would align with the galaxy's complex structure and history, offering a plausible explanation for the phenomenon. The implications of these radiation patterns are profound. If they stem from unknown cosmic processes or objects, they could challenge our current understanding of astrophysics. For example, they might hint at new forms of energy or matter that have yet to be discovered. Additionally, studying these patterns could provide clues about the galaxy's evolution, shedding light on how such energetic events shape the cosmos over time. As we continue to probe the mysteries of NGC 1300, these unusual radiation patterns serve as a reminder of how much we still have to learn. They invite us to question our assumptions and explore the boundaries of our knowledge. Next, we'll venture into another captivating enigma, the galactic vortex, a swirling structure that defies explanation. Stay tuned as we uncover more of the galaxy's hidden wonders. Now, let's turn our attention to a truly mesmerizing feature of NGC 1300, the galactic vortex. This swirling, almost hypnotic structure stands out as one of the galaxy's most baffling phenomena. Unlike typical spiral arms or star clusters, this vortex appears to twist and churn in ways that challenge our understanding of galactic dynamics. What could be causing such a dramatic and unusual formation? One possibility is that the vortex is the result of extreme gravitational forces at play. Imagine a massive object like a black hole or a dense cluster of stars exerting a powerful pull on the surrounding gas and dust. This gravitational tug could create a swirling motion, much like water spiraling down a drain. However, the scale and complexity of the vortex in NGC 1300 suggest that something far more intricate is at work. Some scientists speculate that it might be linked to the galaxy's magnetic fields, which could be twisting and shaping the vortex in ways we're only beginning to understand. Another intriguing theory points to the possibility of a past galactic collision. If NGC 1300 once interacted with another galaxy, the resulting chaos could have triggered the formation of this vortex. The collision might have sent shockwaves through the galaxy, stirring up its gas and dust into this swirling pattern. Over time, the vortex could have stabilized, leaving behind this stunning and mysterious structure. The significance of the galactic vortex extends beyond its visual appeal. Studying it could provide valuable insights into the forces that shape galaxies. For instance, if the vortex is indeed driven by magnetic fields, it could reveal new details about how these fields influence galactic evolution. Alternatively, if it's a remnant of a collision, it could help us piece together the history of NGC 1300 and its interactions with other galaxies. As we continue to unravel the secrets of this cosmic whirlpool, one thing is clear: the galactic vortex is a testament to the complexity and beauty of the universe. It reminds us that even in the vastness of space, there are still phenomena that defy explanation, inviting us to keep exploring and questioning. Up next, we'll delve into another fascinating mystery: the phantom stars of NGC 1300, celestial bodies that emit no visible light yet leave their mark in other ways. Stay with us as we uncover more of the galaxy's hidden wonders. Moving deeper into the mysteries of NGC 1300, we now encounter a phenomenon that challenges our very understanding of what a star can be: the phantom stars. These enigmatic celestial bodies emit no visible light, yet they make their presence known through other, more subtle means. Imagine a star that doesn't shine in the way we expect, one that hides in plain sight, detectable only through the faint whispers of its existence. What could these phantom stars be, and why do they defy our conventional expectations? The mystery begins with how we detect them. Unlike typical stars that light up the night sky, phantom stars are invisible to optical telescopes. Instead, they reveal themselves through other forms of radiation, such as infrared or X-rays. These emissions suggest that these stars are shrouded in dense clouds of dust or gas, which absorb their visible light but allow other wavelengths to escape. This makes them detectable only with specialized instruments, adding to their elusive nature. One leading theory suggests that these phantom stars could be in a late stage of stellar evolution. For instance, they might be white dwarfs or neutron stars, remnants of once bright stars that have exhausted their nuclear fuel. These stellar remnants no longer produce visible light but still emit energy in other forms, such as heat or radio waves. Another possibility is that these stars are surrounded by massive accretion disks, where material spiraling into them emits energy in non-visible wavelengths, effectively masking the star itself. What makes these phantom stars even more intriguing is their potential role in the galaxy's ecosystem. If they are indeed remnants of massive stars, they could be key players in the cycle of stellar birth and death. Their presence might influence the formation of new stars or even contribute to the galaxy's overall structure. Yet, their invisibility makes them difficult to study, leaving many questions unanswered. Are they more common than we think? Could they hold clues to the galaxy's past or future? The phantom stars of NGC 1300 remind us that the universe is full of surprises. They challenge us to look beyond what we can see and to explore the hidden layers of cosmic phenomena. As we continue to study these elusive stars, we may uncover new insights into the life cycles of stars and the intricate workings of galaxies. Next, we'll explore another captivating mystery, the unstable galactic core of NGC 1300, where chaos seems to reign supreme. Stay tuned as we dive deeper into the heart of this enigmatic galaxy. Now, let's turn our attention to the very heart of NGC 1300, a place where chaos seems to rule. The galactic core, typically the most stable and densely packed region of a galaxy, is anything but stable in this mysterious spiral galaxy. Instead of a calm, predictable center, the core of NGC 1300 is in a state of constant flux, shifting and changing in ways that baffle astronomers. What could be causing this instability, and what does it mean for the galaxy as a whole? At the center of most galaxies, including our own Milky Way, lies a supermassive black hole. These colossal objects act as anchors, holding the galaxy together and influencing its structure. However, in NGC 1300, the core behaves as if it's missing this anchor, or perhaps as if the anchor itself is unstable. Observations reveal that the core undergoes dramatic changes in brightness and energy output, suggesting that something unusual is happening deep within. One possibility is that the supermassive black hole at the center of NGC 1300 is not alone. Instead, it might be part of a binary system where two black holes orbit each other. This dynamic duo could create gravitational waves and tidal forces that disrupt the surrounding region, causing the core to appear unstable. Alternatively, the black hole might be feeding on surrounding material at an irregular rate, leading to bursts of energy that make the core seem erratic. Another theory points to the influence of dark matter. While dark matter is invisible, its gravitational effects are profound. If the distribution of dark matter in the core of NGC 1300 is uneven or shifting, it could destabilize the region, causing the observed fluctuations. This would mean that the core's instability is not just a local phenomenon, but a reflection of larger, unseen forces at work. The unstable core of NGC 1300 also raises questions about the galaxy's history. Could this turbulence be the result of a past collision with another galaxy? Such an event could have disrupted the core, leaving it in a state of perpetual unrest. Or perhaps the core's instability is a sign of ongoing processes, like the formation of new stars or the ejection of massive amounts of energy from the central black hole. Whatever the cause, the unstable core of NGC 1300 is a reminder that even the most familiar parts of the universe can hold surprises. It challenges us to rethink our understanding of galactic centers and the forces that shape them. As we continue to study this enigmatic region, we may uncover new insights into the delicate balance that governs galaxies. Next, we'll explore another fascinating mystery, the galactic echo chamber, where signals bounce back repeatedly, creating a cosmic feedback loop. Stay with us as we unravel more secrets of NGC 1300. Now, let's venture into one of the most intriguing regions of NGC 1300, a place where the galaxy seems to talk back to itself. This phenomenon, known as the galactic echo chamber, is a region where signals, whether they're light, radio waves, or other forms of electromagnetic radiation, bounce back repeatedly, creating a cosmic feedback loop. Imagine shouting into a canyon and hearing your voice echo back. Now picture that on a galactic scale. But what causes this strange echoing effect, and what can it tell us about the structure of NGC 1300? At the heart of this mystery lies the galaxy's unique environment. The echo chamber is likely a region filled with dense clouds of gas and dust which act like mirrors, reflecting signals back and forth. These clouds are so thick that they trap radiation, preventing it from escaping easily. Instead, the signals bounce around, creating a repeating pattern that astronomers can detect. This phenomenon is not just a curiosity, it's a window into the galaxy's inner workings, revealing details about its composition and the forces shaping it. One possible explanation for this echoing effect is the presence of massive structures within the galaxy, such as supernova remnants or clusters of young, hot stars. These objects emit intense radiation which interacts with the surrounding gas and dust, causing the signals to scatter and reflect. Over time, this creates a feedback loop where the same signals are detected multiple times, each slightly altered by their journey through the galaxy. This process is similar to how sound echoes in a room, but on a much grander and more complex scale. Another factor contributing to the galactic echo chamber could be the galaxy's magnetic field. Magnetic fields can influence the path of electromagnetic radiation, bending and redirecting it in unexpected ways. In NGC 1300, the magnetic field might be particularly strong or irregular, causing signals to loop back on themselves. This would explain why the echoes are so pronounced and why they persist over long periods of time. The galactic echo chamber also raises questions about the galaxy's history. Could this phenomenon be the result of a past event, such as a collision with another galaxy or a burst of star formation? Such events could have disrupted the galaxy's structure, creating the conditions necessary for signals to bounce back repeatedly. Alternatively, the echo chamber might be a natural feature of NGC 1300, shaped by its unique environment and the forces at play within it. Studying this phenomenon offers valuable insights into the galaxy's composition and behavior. By analyzing the echoes, astronomers can map the distribution of gas and dust, measure the strength of the magnetic field, and even uncover clues about the galaxy's past. It's a reminder that even the most unusual phenomena can serve as tools for understanding the universe. As we move forward, we'll explore another fascinating mystery: phantom black holes, objects that leave no detectable trace yet seem to influence their surroundings in profound ways. Stay with us as we continue to unravel the secrets of NGC 1300, one strange phenomenon at a time. Now, let's turn our attention to one of the most elusive mysteries in NGC 1300, phantom black holes. These enigmatic objects defy detection, leaving no visible trace, yet their presence is inferred through the strange gravitational effects they exert on their surroundings. Imagine a cosmic ghost, invisible yet powerful enough to bend light and warp space-time. But how can something so massive and influential remain hidden? And what does this mean for our understanding of black holes? The concept of phantom black holes challenges our traditional view of these cosmic giants. Typically, black holes are detected through their interactions with nearby matter, such as the accretion disks of swirling gas and dust that emit intense radiation. However, in NGC 1300, astronomers have observed regions where the gravitational pull suggests the presence of a black hole, yet no accompanying radiation or visible matter can be found. This absence of detectable signals has led to the term phantom black holes, as they seem to exist only in the shadows of their gravitational influence. One theory proposes that these phantom black holes could be isolated, having consumed all the nearby matter in their vicinity. Without a steady stream of material to feed on, they would no longer emit the telltale radiation that makes them visible to our instruments. Instead, they would exist in a dormant state, their presence revealed only by the way they distort the paths of light and stars around them. This would make them incredibly difficult to detect, as they would essentially be invisible against the backdrop of space. Another possibility is that these black holes are surrounded by unusually dense clouds of dark matter. dark matter which does not interact with light could effectively cloak the black hole, preventing any radiation from escaping. In this scenario, the gravitational effects of the black hole would still be felt, but its electromagnetic signature would be completely obscured. This would explain why astronomers can infer the presence of a black hole through its gravitational pull but cannot observe it directly. There's also the intriguing idea that phantom black holes might be the remnants of ancient, supermassive black holes that have lost their accretion disks over billions of years. As galaxies evolve, the conditions that once fueled these black holes may change, leaving them isolated and invisible. This would make them relics of a bygone era, offering a glimpse into the early stages of galactic formation and evolution. The existence of phantom black holes raises profound questions about the nature of these cosmic objects and the limits of our observational capabilities. If black holes can exist without emitting detectable radiation, how many more might be lurking in the universe, unseen and unknown? This phenomenon also highlights the importance of gravitational wave astronomy, which can detect the ripples in space-time caused by black hole mergers, even when no light is emitted. As we continue to explore NGC 1300, the mystery of phantom black holes reminds us that the universe is full of surprises, challenging our assumptions and pushing the boundaries of our knowledge. Next, we'll delve into another fascinating aspect of this galaxy unusual star formation, where stars are born at an unprecedented rate. Stay with us as we uncover more of the galaxy's secrets, one phenomenon at a time. Now, shifting our gaze to another extraordinary feature of NGC 1300, we encounter regions where stars are born at a pace that defies expectations. These areas of unusual star formation are like cosmic nurseries on overdrive, producing stars at a rate that leaves astronomers both amazed and puzzled. What could possibly fuel such a rapid burst of stellar creation in this galaxy? One of the key factors driving this phenomenon is the abundance of gas and dust in these regions. NGC 1300 is rich in the raw materials needed for star formation, with vast clouds of molecular gas providing the perfect environment for new stars to ignite. When these clouds collapse under their own gravity, they fragment into smaller clumps, each of which can give birth to a star. In NGC 1300, this process seems to be happening at an accelerated rate, leading to an unusually high number of stars forming simultaneously. Another contributing factor could be the galaxy's dynamic environment. NGC 1300 is a barred spiral galaxy, and its central bar plays a significant role in funneling gas toward the inner regions. This influx of gas creates dense, turbulent conditions that are ideal for triggering star formation. The bar's gravitational influence can compress the gas, causing it to collapse more quickly and efficiently than in other parts of the galaxy. This might explain why certain regions in NGC 1300 are teeming with newborn stars. Additionally, interactions with neighboring galaxies or past galactic collisions could have stirred up the gas in NGC 1300, creating shock waves that compress the material and kickstart star formation. While there's no direct evidence of recent collisions, the galaxy's history might hold clues to its current state of rapid stellar birth. These interactions could have left behind pockets of highly concentrated gas, acting as hotspots for star formation. The role of dark matter cannot be overlooked either. Dark matter, which makes up a significant portion of the galaxy's mass, could be influencing the distribution of gas and the overall dynamics of star formation. By shaping the gravitational landscape, dark matter might be indirectly contributing to the accelerated rate at which stars are being born in NGC 1300. This unusual star formation raises intriguing questions about the life cycle of galaxies and the conditions that lead to such prolific stellar activity. It also highlights the delicate balance between the forces that drive star formation and those that regulate it. As we continue to study NGC 1300, these regions of rapid star birth offer a unique opportunity to understand the processes that shape galaxies over time. Next, we'll explore another captivating mystery, the galactic time capsule, a region in NGC 1300 that seems to preserve ancient cosmic events. Join us as we uncover more of the galaxy's hidden stories, one phenomenon at a time. Now, let's turn our attention to a truly remarkable feature of NGC 1300, a region that acts as a galactic time capsule, preserving ancient cosmic events like a snapshot of the universe's distant past. This area offers astronomers a rare glimpse into the early stages of galactic evolution, providing clues about how galaxies like NGC 1300 came to be. What makes this region so extraordinary is its ability to retain traces of events that occurred billions of years ago. Imagine it as a cosmic archive where the remnants of ancient star formations, supernovae, and even interactions with other galaxies are frozen in time. These preserved features allow scientists to piece together the history of NGC 1300, much like archaeologists uncovering artifacts from a long-lost civilization. One of the most fascinating aspects of this time capsule is the presence of ancient star clusters. These clusters are composed of some of the oldest stars in the galaxy, formed during its earliest stages. By studying their composition and distribution, researchers can infer the conditions that existed when NGC 1300 was just beginning to take shape. These stars act as cosmic fossils, offering insights into the raw materials and processes that fueled the galaxy's growth. Another key feature of this region is the presence of unusually stable gas clouds. Unlike the turbulent, star-forming regions we discussed earlier, these clouds have remained relatively undisturbed for billions of years. Their stability has allowed them to retain their original chemical composition, providing a pristine record of the elements present in the early universe. This makes them invaluable for understanding how the first generations of stars and galaxies formed and evolved. The significance of this galactic time capsule extends far beyond NGC 1300 itself. By studying this region, astrophysicists can test theories about the formation and evolution of galaxies across the universe. It serves as a natural laboratory, offering a unique opportunity to observe processes that are otherwise difficult to study directly. For example, the preserved remnants of ancient supernovae can shed light on how these explosive events shaped the chemical makeup of galaxies over time. Moreover, this region challenges our understanding of how galaxies retain their history. Typically, the dynamic nature of galaxies with their swirling arms, collisions, and star formation tends to erase evidence of past events. Yet, in this part of NGC 1300, the past remains remarkably intact. This raises intriguing questions about the forces that have protected this region from the usual wear and tear of galactic life. As we continue to explore NGC 1300, the galactic time capsule stands as a testament to the enduring mysteries of the cosmos. It reminds us that galaxies are not just collections of stars and gas, but also repositories of history, holding secrets that can help us unravel the story of the universe itself. Next, we'll delve into another enigmatic feature of this galaxy, the phantom galaxies, smaller structures within NGC 1300 that appear and disappear, leaving astronomers puzzled. Stay with us as we uncover more of the galaxy's hidden wonders. Now, shifting our gaze to another layer of mystery within NGC 1300, we encounter the phenomenon of phantom galaxies, smaller structures that seem to flicker in and out of existence. These elusive formations have left astronomers both fascinated and perplexed as they challenge our understanding of galactic behavior and stability. Phantom galaxies are not your typical cosmic neighbors. Unlike the steady, enduring presence of most galaxies, these smaller structures appear to vanish and reappear over time, as if playing a cosmic game of hide and seek. Observations suggest that they might be temporary or transient in nature, but the reasons behind their erratic behavior remain unclear. Some theories propose that these phantom galaxies could be the remnants of past galactic collisions, fragments torn away during interactions with larger galaxies like NGC 1300. Over time, these fragments might dissipate or merge back into the larger structure, explaining their fleeting appearances. Another intriguing possibility is that these phantom galaxies are not entirely physical in nature. Instead, they could be optical illusions caused by gravitational lensing, where the immense gravity of NGC 1300 bends and distorts light from more distant objects. This distortion could create the illusion of smaller galaxies appearing and disappearing as the alignment of light sources changes over time. If this is the case, these phantom galaxies might not be independent structures at all, but rather mirages created by the interplay of light and gravity. Alternatively, some researchers speculate that these phantom galaxies could be the result of dark matter interactions. Dark matter, which makes up a significant portion of the universe's mass, is invisible and interacts only through gravity. It's possible that clumps of dark matter within NGC 1300 could temporarily gather enough visible matter to form a detectable structure, only to disperse again as the dark matter moves on. This would explain why these galaxies seem to vanish without a trace. The study of phantom galaxies also raises questions about the life cycle of smaller galactic structures. Are they doomed to be absorbed by larger galaxies, or do they have the potential to survive and evolve independently? Understanding their origins and behavior could provide valuable insights into the processes that govern galactic formation and evolution on a smaller scale. As we continue to explore NGC 1300, the mystery of phantom galaxies serves as a reminder of how much we still have to learn about the cosmos. These fleeting structures challenge our assumptions and push the boundaries of our knowledge, inviting us to rethink what we know about the universe's smaller inhabitants. Next, we'll turn our attention to another puzzling aspect of this galaxy, the unstable dark energy that seems to fluctuate within its boundaries. Stay with us as we unravel more of NGC 1300's secrets. Now, as we delve deeper into the enigmatic heart of NGC 1300, we encounter a phenomenon that challenges our very understanding of the universe's fabric: unstable dark energy. Dark energy, the mysterious force driving the accelerated expansion of the cosmos, is thought to be a constant presence across the universe. Yet, within this galaxy, it appears to behave in ways that defy expectations, fluctuating unpredictably and raising profound questions about the nature of this elusive force. Dark energy is already one of the greatest mysteries in modern astrophysics. It's believed to make up around 70% of the universe's energy content, acting as a kind of anti-gravity that pushes galaxies apart. In most regions of space, its influence is steady and uniform, but in NGC 1300, observations suggest that dark energy is anything but stable. Instead, it seems to ebb and flow, creating pockets where its effects are stronger or weaker than expected. These fluctuations could have significant implications for the galaxy's expansion and overall structure. One theory suggests that these irregularities might be tied to the galaxy's unique environment. NGC 1300 is a spiral galaxy with a complex structure, including its unusual spiral arms and the presence of dark matter halos. These features could interact with dark energy in ways we don't yet fully understand, causing it to behave erratically. For instance, the distribution of dark matter within the galaxy might create localized variations in gravitational fields, which in turn could influence how dark energy manifests. Another possibility is that dark energy itself is not as uniform as we once thought. While it's often described as a constant force, some models propose that it could vary over time or across different regions of space. If this is true, NGC 1300 might be a rare example of a galaxy where these variations are particularly pronounced. This would challenge the standard cosmological model, which assumes dark energy is consistent everywhere. The implications of unstable dark energy are far-reaching. If dark energy fluctuates within NGC 1300, it could affect the galaxy's rate of expansion, potentially causing some regions to expand faster than others. This uneven expansion might explain certain anomalies observed in the galaxy, such as the irregular distribution of gas or the peculiar behavior of its star clusters. It could also influence the galaxy's long-term evolution, shaping its future in ways that differ from other galaxies. Understanding these fluctuations could also shed light on the broader nature of dark energy. If we can determine why it behaves differently in NGC 1300, we might gain insights into its fundamental properties. This could help us answer some of the biggest questions in cosmology, such as why the universe is expanding at an accelerating rate and what the ultimate fate of the cosmos might be. As we continue to explore NGC 1300, the mystery of unstable dark energy reminds us that the universe is far more complex and dynamic than we often assume. It challenges us to rethink our assumptions and pushes the boundaries of our knowledge, inviting us to uncover the secrets of this enigmatic force. Next, we'll turn our attention to another fascinating aspect of this galaxy: the galactic sound waves that ripple through its vast expanse. Stay with us as we uncover more of NGC 1300's hidden wonders. Now, shifting our focus to another extraordinary feature of NGC 1300, we encounter a phenomenon that defies our usual understanding of space galactic sound waves. Unlike the silence we associate with the vacuum of space, this galaxy resonates with low-frequency vibrations that ripple through its vast expanse, creating a cosmic symphony that scientists are only beginning to decode. Sound waves, as we know them on Earth, require a medium like air or water to travel. In space, where such mediums are absent, the concept of sound might seem impossible. However, in the dense environments of galaxies like NGC 1300, sound waves can indeed propagate, carried by the hot gas that fills the space between stars. These waves are not the kind we can hear with our ears. Instead, they manifest as pressure waves moving through the interstellar medium and leaving behind detectable patterns. The origins of these galactic sound waves are deeply tied to the dynamic processes occurring within the galaxy. One of the primary sources is the formation and explosion of massive stars. When a star explodes as a supernova, it releases an enormous amount of energy, creating shockwaves that ripple through the surrounding gas. These shockwaves can travel vast distances, compressing and heating the interstellar medium as they go, and leaving behind a signature that astronomers can observe. Another potential source of these sound waves is the activity of the galaxy's supermassive black hole, or in the case of NGC 1300, the absence of one. Even without a central black hole, the galaxy's core is a hotbed of activity, with intense gravitational interactions and the movement of gas and dust generating waves that propagate outward. These waves can carry information about the inner workings of the galaxy, offering clues about its structure and evolution. The significance of these sound waves lies in what they reveal about the galaxy's environment. By studying their patterns, scientists can map the distribution of gas and dust within NGC 1300, gaining insights into how these materials are distributed and how they influence star formation. The waves also provide a way to measure the temperature and density of the interstellar medium, helping astronomers understand the conditions that shape the galaxy's evolution. Moreover, these sound waves can act as a kind of cosmic echo, preserving information about past events. For example, a supernova that occurred millions of years ago might still be detectable through the ripples it left behind. This makes galactic sound waves a valuable tool for studying the history of NGC 1300, allowing scientists to piece together a timeline of its most dramatic events. The study of these waves also has broader implications for our understanding of the universe. By analyzing how sound travels through different regions of space, researchers can test theories about the behavior of matter and energy under extreme conditions. This could lead to new insights into the fundamental forces that govern the cosmos, from gravity to the interactions of dark matter and dark energy. As we continue to explore NGC 1300, the discovery of galactic sound waves reminds us that the universe is full of surprises. What we once thought of as a silent void is, in reality, a dynamic and vibrant space filled with phenomena that challenge our understanding and inspire us to look deeper. Next, we'll uncover another layer of this galaxy's mysteries: phantom comets that appear and vanish without a trace. Stay tuned as we journey further into the enigmatic heart of NGC 1300. Now, as we venture deeper into the mysteries of NGC 1300, we encounter a phenomenon that seems to defy logic: phantom comets. These elusive celestial bodies appear to materialize out of nowhere, only to vanish just as suddenly, leaving astronomers puzzled and intrigued. Unlike the comets we're familiar with in our own solar system, these phantom comets don't follow predictable paths or leave behind the characteristic tails of gas and dust. Instead, they flicker in and out of existence, challenging our understanding of how such objects behave in the depths of space. One theory suggests that these phantom comets might not be comets at all, but rather fragments of larger objects that have been torn apart by the galaxy's intense gravitational forces. In the chaotic environment of NGC 1300, where stars, gas, and dust are constantly interacting, it's possible that these fragments are briefly illuminated by nearby stellar activity, only to fade away as they move into darker regions of the galaxy. This would explain their sudden appearances and disappearances, as they are only visible when conditions are just right. Another possibility is that these phantom comets are the remnants of ancient collisions between icy bodies in the outer reaches of the galaxy. Over billions of years, these collisions could have produced a population of small, icy fragments that occasionally drift into regions where they are heated by nearby stars, causing them to briefly glow before sublimating into gas. This process would create the illusion of comets appearing and vanishing, as the fragments are too small and faint to be detected once they lose their icy coatings. Some researchers have even proposed that these phantom comets could be linked to the galaxy's mysterious dark matter halo. If dark matter interacts with ordinary matter in ways we don't yet fully understand, it's possible that it could influence the behavior of these comets, causing them to appear and disappear in ways that seem almost magical. While this idea is still speculative, it highlights the many unknowns that surround NGC 1300 and the strange phenomena within it. The study of these phantom comets is not just about solving a cosmic puzzle, it also offers valuable insights into the processes that shape galaxies. By understanding how these objects form and behave, scientists can learn more about the distribution of matter in NGC 1300, as well as the forces that drive its evolution. Each fleeting glimpse of a phantom comet adds another piece to the puzzle, helping us build a clearer picture of this enigmatic galaxy. As we continue to explore the wonders of NGC 1300, the mystery of the phantom comets reminds us that the universe is full of surprises. These ghostly visitors challenge our assumptions and push the boundaries of what we thought was possible, inspiring us to keep searching for answers. Next, we'll turn our attention to another intriguing phenomenon: unusual cosmic rays that defy standard models. Stay with us as we uncover more secrets hidden within this fascinating galaxy. Now, shifting our gaze to another layer of NGC 1300's mysteries, we encounter a phenomenon that challenges our understanding of cosmic radiation: unusual cosmic rays. These high-energy particles, which typically originate from sources like supernova or black holes, behave in ways that don't align with the standard models scientists have developed over decades. In NGC 1300, cosmic rays seem to carry energies far beyond what we'd expect, and their patterns of distribution are anything but ordinary. One leading theory suggests that these cosmic rays might be accelerated by the galaxy's turbulent magnetic fields. In regions where the magnetic field is exceptionally strong and chaotic, particles could be propelled to extraordinary speeds, gaining energy levels that defy conventional explanations. This process, known as magnetic reconnection, occurs when magnetic field lines break and reconnect, releasing vast amounts of energy. If this is happening on a massive scale in NGC 1300, it could explain the unusually high energy cosmic rays detected there. Another possibility is that these cosmic rays are being produced by an unknown, highly energetic source within the galaxy. Some researchers speculate that a hidden population of neutron stars or black holes could be responsible. These dense, compact objects are known to emit powerful jets of particles and radiation, which could contribute to the unusual cosmic ray activity observed. However, the exact nature of these sources remains elusive, as they don't match the behavior of any known objects in the galaxy. There's also the intriguing idea that dark matter might play a role in this phenomenon. If dark matter particles interact with ordinary matter in ways we don't yet understand, they could be producing high-energy cosmic rays as a byproduct. While this remains a speculative theory, it's an exciting avenue of research that could shed light on both the nature of dark matter and the strange cosmic rays in NGC 1300. Studying these unusual cosmic rays isn't just about solving a scientific puzzle. It's also about understanding the broader processes that shape galaxies. Cosmic rays play a crucial role in heating interstellar gas, influencing star formation, and even shaping the evolution of galaxies. By unraveling the mystery of these high-energy particles, scientists can gain deeper insights into the forces at work in NGC 1300 and beyond. As we continue to explore the galaxy's many enigmas, the unusual cosmic rays serve as a reminder of how much we still have to learn about the universe. These particles, with their extraordinary energies and mysterious origins, challenge our assumptions and push the boundaries of astrophysics. Next, we'll delve into another fascinating feature of NGC 1300, the galactic lens, a region that magnifies distant objects in ways that defy explanation. Stay with us as we uncover more of the galaxy's secrets. Now, let's turn our attention to a phenomenon that seems to bend the rules of light itself, the galactic mirror. In a specific region of NGC 1300, light behaves in ways that defy our expectations, creating reflections and distortions that are nothing short of mesmerizing. This area, often referred to as the galactic mirror, acts almost like a cosmic funhouse, bending and reflecting light in patterns that challenge our understanding of optics and space. At the heart of this phenomenon lies a combination of gravitational lensing and interstellar dust. Gravitational lensing occurs when the immense gravity of a massive object, like a cluster of stars or dark matter, warps the fabric of space-time. This warping bends the path of light traveling through it, much like a magnifying glass bends light. In the case of NGC 1300, this effect is amplified by the presence of dense dust clouds, which scatter and reflect light in unpredictable ways. Together, these factors create a region where light appears to bounce and twist, producing reflections that seem almost otherworldly. One of the most striking features of the galactic mirror is its ability to magnify distant objects. Light from stars or galaxies far beyond NGC 1300 can be bent and focused by this region, making them appear brighter and more detailed than they would otherwise. This effect has allowed astronomers to observe distant cosmic objects with unprecedented clarity, offering a unique window into the early universe. However, the reflections and distortions also make it challenging to interpret what we're seeing, as the light can be bent into multiple images or stretched into strange shapes. Another intriguing aspect of the galactic mirror is its role in revealing the distribution of dark matter. By studying how light is bent and reflected in this region, scientists can map the invisible dark matter that permeates the galaxy. Dark matter doesn't emit or reflect light, but its gravitational influence on light passing through it provides clues about its presence and distribution. The galactic mirror, with its complex interplay of light and gravity, serves as a natural laboratory for studying this elusive substance. But why does this region behave so differently from the rest of the galaxy? One theory suggests that the galactic mirror is the result of a past collision or interaction with another galaxy. Such an event could have disrupted the distribution of dust and dark matter, creating the conditions necessary for this unusual light-bending phenomenon. Alternatively, it could be a region where star formation has been particularly intense, producing dense clouds of dust and gas that scatter light in unique ways. As we continue to study the galactic mirror, it raises fascinating questions about the nature of light, gravity, and the structure of galaxies. This phenomenon not only challenges our understanding of how light behaves in space, but also provides valuable insights into the hidden forces shaping NGC 1300. Next, we'll explore another mysterious feature of this galaxy: phantom moons, objects that appear and vanish in ways that defy explanation. Stay with us as we uncover more of the galaxy's secrets. Now, let's shift our focus to a phenomenon that seems to play tricks on our understanding of celestial bodies: phantom moons. In NGC 1300, astronomers have observed mysterious objects that behave like moons, appearing and vanishing without warning. These phantom moons defy conventional explanations, leaving scientists puzzled about their true nature and origins. The first reports of these elusive objects came from observations of NGC 1300's outer regions. Telescopes captured what appeared to be small, moon-like bodies orbiting the galaxy's larger planets. However, upon closer inspection, these objects would vanish, only to reappear in a different location or not at all. This erratic behavior has led to intense speculation about what these phantom moons could be. One leading theory suggests that these objects might not be moons in the traditional sense, but rather dense clouds of dust and gas. These clouds could temporarily reflect light in a way that mimics the appearance of a solid body. Over time, as the clouds disperse or shift, the illusion of a moon would fade, explaining their sudden disappearance. This idea aligns with the presence of irregular gas and dust distributions observed elsewhere in NGC 1300. Another possibility is that these phantom moons are the remnants of past cosmic collisions. When smaller celestial bodies collide with larger planets or moons, debris can be ejected into orbit. This debris might clump together temporarily, creating the illusion of a moon before gravitational forces or radiation cause it to break apart or drift away. Such a scenario would explain why these objects appear and vanish unpredictably. A more intriguing hypothesis involves the influence of dark matter. Some scientists speculate that dark matter could be interacting with visible matter in ways we don't yet fully understand. These interactions might create temporary gravitational anomalies, causing objects to appear and disappear as they pass through regions of concentrated dark matter. While this idea is still speculative, it highlights the potential role of dark matter in shaping the galaxy's most mysterious phenomena. The study of phantom moons also raises questions about the stability of planetary systems in NGC 1300. If these objects are indeed transient, their presence could indicate a dynamic and ever-changing environment within the galaxy. This instability might affect the formation and evolution of planets and moons, offering new insights into the processes that shape galactic systems. As we continue to investigate these phantom moons, they remind us of how much we still have to learn about the universe. Their elusive nature challenges our ability to observe and understand the cosmos, pushing the boundaries of astronomy and astrophysics. Next, we'll explore another enigmatic feature of NGC 1300 unstable star systems that exhibit behavior unlike anything we've seen before. Stay with us as we delve deeper into the galaxy's mysteries. Now, let's turn our attention to a phenomenon that challenges our understanding of how star systems behave: unstable star systems in NGC 1300. These systems are unlike anything we've observed in other galaxies, with stars that seem to defy the usual rules of cosmic order. Their erratic movements and unpredictable behavior have left astronomers scratching their heads, searching for answers to what could be causing such instability. One of the most striking features of these unstable star systems is their irregular orbits. In a typical star system, planets and stars follow predictable paths governed by gravity. But in NGC 1300, some stars appear to wobble, speed up, or even reverse direction without any apparent cause. This chaotic motion suggests that something is disrupting the gravitational balance within these systems, but what exactly remains a mystery. One possible explanation lies in the presence of rogue objects. These could be massive planets, black holes, or even remnants of past collisions that wander through the star systems, exerting gravitational forces strong enough to destabilize the orbits of nearby stars. Imagine a cosmic game of billiards where a rogue object enters the scene, sending stars careening off their usual paths. This scenario could explain the erratic behavior observed in these systems. Another theory points to the influence of dark matter. While dark matter is invisible, its gravitational effects are profound. In NGC 1300, pockets of concentrated dark matter might be interacting with star systems, creating gravitational anomalies that disrupt their stability. These interactions could cause stars to behave unpredictably, as if they're being tugged by unseen forces. While this idea is still speculative, it offers a fascinating glimpse into how dark matter might shape the galaxy's most chaotic regions. The instability of these star systems also raises questions about their long-term survival. In a stable system, stars and planets can coexist for billions of years, but in these erratic environments, the constant gravitational tug of war could lead to collisions, ejections, or even the destruction of entire systems. This instability might also affect the formation of new stars and planets, creating a cycle of chaos that perpetuates itself over time. Studying these unstable star systems not only deepens our understanding of NGC 1300, but also challenges our assumptions about how star systems form and evolve. Their unpredictable nature reminds us that the universe is full of surprises, and even the most well-established theories can be upended by new discoveries. As we continue to explore these enigmatic systems, we're reminded of the vast complexity of the cosmos and the endless mysteries waiting to be uncovered. Next, we'll venture into another intriguing aspect of NGC 1300, a region where time itself seems to warp and flow differently. Stay with us as we unravel the secrets of the galactic time warp, a phenomenon that defies our understanding of space and time. Now, let's journey into one of the most mind-bending phenomena in NGC 1300, a region where time itself seems to twist and bend, creating what scientists call a galactic time warp. Imagine stepping into a part of the galaxy where the rules of time as we know them no longer apply. This isn't science fiction. It's a real cosmic mystery that challenges our understanding of physics and the very fabric of reality. In this peculiar region of NGC 1300, time doesn't flow at a constant rate. Instead, it appears to speed up, slow down, or even loop back on itself in ways that defy our everyday experience. This phenomenon, known as time dilation, is a concept predicted by Einstein's theory of relativity, but the scale and intensity observed here are unlike anything we've seen before. It's as if the galaxy has its own cosmic clock, ticking at a rhythm that doesn't match the rest of the universe. One possible explanation for this time warp lies in the immense gravitational forces at play. In areas where gravity is extraordinarily strong, such as near massive objects like black holes or dense clusters of stars, time can slow down significantly. In NGC 1300, there may be hidden gravitational giants, objects so massive and dense that they warp the fabric of space-time itself. These objects could be creating pockets where time flows at a different pace, effectively creating a galactic-scale time machine. Another intriguing possibility is the influence of dark energy. This mysterious force, which drives the accelerated expansion of the universe, might interact with space-time in unexpected ways within NGC 1300. If dark energy is unevenly distributed or concentrated in certain regions, it could create distortions in time, causing it to flow differently in those areas. While this idea is still speculative, it opens up fascinating questions about the relationship between dark energy and the structure of space-time. The implications of this time warp are profound. If time can flow differently in one part of the galaxy, what does that mean for our understanding of the universe? Could there be regions where time stands still or even runs backward? These questions push the boundaries of physics and force us to rethink our assumptions about the nature of time itself. The galactic time warp in NGC 1300 serves as a cosmic laboratory, offering clues to some of the most fundamental mysteries of the universe. As we continue to study this phenomenon, we're reminded that the universe is far stranger and more complex than we can imagine. The galactic time warp not only challenges our understanding of physics, but also invites us to explore the deeper connections between space, time, and the forces that shape our reality. And with that, we'll move on to another fascinating mystery: phantom asteroids that appear and vanish without a trace. Stay tuned as we uncover more of the galaxy's secrets. Now, let's turn our attention to another cosmic enigma within NGC 1300: phantom asteroids that seem to appear and vanish as if playing a cosmic game of hide and seek. These mysterious objects defy our expectations, leaving astronomers puzzled and sparking a wave of theories about their origins and behavior. Phantom asteroids are unlike anything we've encountered in our own solar system. They're detected briefly, often appearing as faint, fast-moving points of light, only to disappear without a trace. Some vanish within hours or days, while others linger for weeks before fading into the void. This erratic behavior makes them incredibly difficult to study, and their fleeting nature has earned them the nickname "ghost rocks" among researchers. One leading theory suggests these phantom asteroids could be remnants of a larger celestial body that shattered in a violent collision. When two massive objects collide, they can produce a cloud of debris, some of which may be too small or faint to detect consistently. Over time, these fragments could drift apart or be pulled into the gravitational influence of nearby stars or black holes, causing them to vanish from our observations. This would explain why they appear and disappear so unpredictably. Another possibility is that these asteroids are not solid objects at all, but rather clumps of dust and gas held together by weak gravitational forces. In the chaotic environment of NGC 1300, these fragile structures could form temporarily, only to be torn apart by tidal forces or radiation from nearby stars. This would make them appear briefly before disintegrating, leaving no trace behind. There's also the intriguing idea that these phantom asteroids could be influenced by dark matter. If dark matter interacts with ordinary matter in ways we don't yet understand, it might create temporary gravitational anomalies that cause asteroids to appear and vanish. While this theory is highly speculative, it highlights the potential role of dark matter in shaping the behavior of celestial objects within the galaxy. The implications of these phantom asteroids are significant. If they are indeed remnants of past collisions, they could provide clues about the history of NGC 1300 and the frequency of catastrophic events within the galaxy. Alternatively, if they're linked to dark matter or other unknown forces, they could open up entirely new avenues of research into the fundamental nature of the universe. As we continue to explore NGC 1300, these phantom asteroids remind us that the galaxy is full of surprises. Their mysterious behavior challenges our understanding of celestial mechanics and invites us to rethink what we know about the cosmos. And with that, we'll move on to another captivating phenomenon: unusual galactic winds that sweep through the galaxy with incredible force. Stay tuned as we uncover more of the galaxy's secrets. Now, shifting our gaze to another extraordinary feature of NGC 1300, we encounter the phenomenon of unusual galactic winds. These winds are not your typical cosmic breeze. They are powerful, fast-moving streams of gas and particles that sweep through the galaxy with astonishing force, leaving scientists both fascinated and perplexed. Unlike the gentle stellar winds we observe in other galaxies, the winds in NGC 1300 are intense and unpredictable. They travel at speeds that can reach hundreds of kilometers per second, carrying vast amounts of energy and material across the galaxy. What makes these winds so unusual is their sheer power and the fact that they don't align with the typical patterns seen in spiral galaxies. In most cases, galactic winds are driven by star formation or the activity of supermassive black holes, but in NGC 1300, the source of these winds remains a mystery. One possible explanation is that these winds are fueled by an unusually high rate of star formation in certain regions of the galaxy. When massive stars are born, they emit intense radiation and stellar winds, which can push surrounding gas outward at incredible speeds. Over time, this process could generate the powerful winds we observe. However, the scale and intensity of the winds in NGC 1300 far exceed what would be expected from star formation alone, suggesting that another force might be at play. Another theory points to the possibility of an active galactic nucleus, or AN, hidden within the galaxy. AGNs are powered by supermassive black holes that consume vast amounts of material, releasing enormous amounts of energy in the process. This energy can drive powerful outflows of gas, creating the kind of winds we see in NGC 1300. Yet, despite extensive observations, no clear evidence of an AGN has been found in the galaxy, leaving this theory in question. There's also the intriguing idea that these winds could be influenced by dark matter. If dark matter interacts with ordinary matter in ways we don't yet understand, it might generate forces that propel gas and particles outward, creating the unusual winds. While this remains speculative, it underscores the potential role of dark matter in shaping the behavior of galaxies. The implications of these galactic winds are profound. They play a crucial role in shaping the structure and evolution of NGC 1300, redistributing gas and influencing star formation. By studying these winds, scientists hope to gain insights into the forces that drive galactic dynamics and the processes that shape the universe on a larger scale. As we continue to unravel the mysteries of NGC 1300, these unusual winds remind us of the galaxy's complexity and the many questions that remain unanswered. Their existence challenges our understanding of galactic behavior and invites us to explore new possibilities. And with that, we'll move on to another fascinating phenomenon: the galactic lens, a region in the galaxy that magnifies distant objects in ways that defy explanation. Stay tuned as we delve deeper into the secrets of this extraordinary galaxy. Now, let's turn our attention to one of the most mind-bending features of NGC 1300, the galactic lens. This remarkable region acts like a cosmic magnifying glass, bending and amplifying light from distant objects in ways that challenge our understanding of space and time. Imagine looking through a telescope and seeing a faraway galaxy appear larger and brighter than it should, all thanks to the gravitational influence of this galactic lens. It's a phenomenon that not only captivates astronomers but also provides a unique window into the distant universe. The science behind this effect lies in a concept known as gravitational lensing. When a massive object, like a galaxy or cluster of galaxies, lies between us and a distant light source, its immense gravity warps the fabric of space-time. This warping acts like a lens, bending the path of light as it travels toward us. In the case of NGC 1300, certain regions of the galaxy are dense enough to create this lensing effect, magnifying the light from objects that would otherwise be too faint or distant to observe. What makes the galactic lens in NGC 1300 particularly fascinating is its precision. Unlike some gravitational lenses that distort images into arcs or rings, this region produces clear, magnified views of distant galaxies and quasars. This clarity allows scientists to study these far-off objects in unprecedented detail, offering insights into their composition, structure, and evolution. It's like having a natural telescope embedded within the galaxy itself, one that reveals the hidden corners of the cosmos. But the galactic lens isn't just a tool for observation. It's also a key to understanding the distribution of mass within NGC 1300. By analyzing how light bends around the lens, astronomers can map the galaxy's dark matter, the invisible substance that makes up a significant portion of its mass. This mapping helps us piece together the galaxy's structure and the role dark matter plays in shaping its behavior. In a way, the galactic lens acts as a cosmic detective, uncovering clues about the unseen forces that govern the universe. The implications of this phenomenon extend far beyond NGC 1300. Gravitational lensing has become a cornerstone of modern astrophysics, enabling discoveries like the measurement of the universe's expansion rate and the detection of exoplanets in distant star systems. The galactic lens in NGC 1300 serves as a reminder of how interconnected the cosmos truly is, with even the most distant objects influencing what we see and learn. As we marvel at this cosmic magnifying glass, we're reminded of the endless wonders that NGC 1300 holds. The galactic lens not only magnifies distant objects but also amplifies our curiosity, driving us to explore the mysteries of the universe with ever greater depth. And with that, we'll move on to another intriguing phenomenon: phantom neutron stars, mysterious objects that seem to vanish without a trace. Stay tuned as we continue our journey through the enigmatic galaxy of NGC 1300. Now, let's shift our focus to one of the most elusive mysteries in NGC 1300: phantom neutron stars. These enigmatic objects are neutron stars that seem to vanish without leaving any detectable trace, defying our understanding of stellar remnants. Neutron stars, the dense cores left behind after massive stars explode in supernova, are typically some of the most observable objects in the universe due to their intense magnetic fields and rapid spins. But in NGC 1300, some neutron stars appear to exist only briefly before disappearing entirely, leaving astronomers puzzled. Theories about these phantom neutron stars range from the plausible to the extraordinary. One possibility is that they are undergoing a process known as quenching, where their magnetic fields or rotational energy dissipate so rapidly that they become invisible to our instruments. Another idea suggests that these stars might be cloaked by dense clouds of interstellar dust or gas, effectively hiding them from view. However, the most intriguing theory proposes that these neutron stars could be transitioning into a new, unknown state of matter, one that renders them undetectable by current technology. What makes this phenomenon even more fascinating is its potential to challenge our understanding of stellar evolution. Neutron stars are already extreme objects, packing the mass of a star into a sphere no larger than a city. If some of these stars can vanish without a trace, it raises questions about the limits of our knowledge. Could there be an entire population of neutron stars that we're missing? And if so, what does that mean for our models of how stars live and die? The implications of phantom neutron stars extend beyond NGC 1300. If these objects exist, they could represent a new class of celestial phenomena, one that requires us to rethink our approach to observing the universe. They might also hold clues about the nature of dark matter or the behavior of matter under extreme conditions, offering a window into physics that we've yet to fully comprehend. As we ponder the mystery of these vanishing stars, we're reminded once again of the boundless complexity of the cosmos. Phantom neutron stars are a testament to the fact that, even in a galaxy as well studied as NGC 1300, there are still secrets waiting to be uncovered. And with that, we'll move on to another captivating phenomenon, the unstable galactic disk, a region of the galaxy that twists and warps in ways that defy explanation. Stay tuned as we continue our exploration of the strange and wondrous NGC 1300. Now, let's turn our attention to another baffling feature of NGC 1300, the unstable galactic disk. Unlike the smooth, flat disks we often associate with spiral galaxies, the disk of NGC 1300 behaves in ways that defy expectations. It twists, warps, and shifts unpredictably, creating a dynamic and chaotic structure that has left astronomers scratching their heads. This instability is not just a visual oddity, it has profound implications for how we understand the formation and evolution of galaxies. One leading theory suggests that the instability could be the result of gravitational interactions with nearby galaxies. Over billions of years, even a distant encounter with another galaxy could tug on the disk, causing it to warp and ripple like a stone dropped into a pond. Another possibility is that the galaxy's own internal dynamics are at play. For instance, the distribution of dark matter within NGC 1300 might be uneven, creating gravitational imbalances that distort the disk over time. Alternatively, the galaxy's central bar, a dense, elongated structure at its core, could be influencing the disk's behavior, sending waves of instability outward. What makes this phenomenon particularly intriguing is its rarity. While many galaxies exhibit some degree of warping, the level of instability seen in NGC 1300 is unusual. This raises questions about whether the galaxy is undergoing a unique phase of evolution or if it's responding to forces we've yet to fully understand. Could there be an unseen companion galaxy or perhaps a massive cloud of gas exerting its influence from the shadows? Or is this instability a sign of something even more exotic, like the presence of a hidden black hole or an unusual concentration of dark energy? The unstable disk also has practical implications for star formation. In a stable galaxy, stars tend to form in predictable patterns along the spiral arms. But in NGC 1300, the warping and twisting of the disk could disrupt these processes, leading to irregular star formation rates and unusual stellar distributions. This, in turn, affects the galaxy's overall structure and evolution, creating a feedback loop of instability. As we explore the mysteries of NGC 1300's unstable disk, we're reminded of just how dynamic and unpredictable the universe can be. This phenomenon challenges our assumptions about galactic stability and invites us to reconsider the forces that shape the cosmos. And with that, we'll move on to another fascinating feature of this galaxy, the galactic echoes of light, where repeated light patterns create a cosmic symphony of mystery. Stay with us as we continue our journey through the strange and wondrous NGC 1300. Now, let's shift our gaze to a phenomenon that feels almost poetic in its mystery, the galactic echoes of light in NGC 1300. Imagine standing in a vast canyon, shouting and hearing your voice bounce back as an echo. Now, picture that same concept but on a cosmic scale. In NGC 1300, astronomers have detected repeated patterns of light that behave like echoes, rippling through the galaxy in ways that defy simple explanation. These light echoes are not just fleeting flashes, they linger, repeating and fading in a rhythm that seems almost deliberate, So, what could be causing these strange light patterns? One possibility is that they're the result of massive stellar explosions, such as supernova. When a star explodes, it sends out a burst of light that can reflect off nearby clouds of gas and dust, creating a delayed echo effect. In NGC 1300, these echoes might be amplified by the galaxy's unique structure, with its dense spiral arms and irregular gas distribution acting like cosmic mirrors. Another theory suggests that the echoes could be linked to the galaxy's central bar, which might channel and reflect light in unusual ways, creating these repeating patterns. But there's another layer to this mystery. Some researchers believe that the echoes could be tied to the galaxy's unstable magnetic field, which we discussed earlier. If the magnetic field fluctuates dramatically, it could influence how light travels through the galaxy, bending and reflecting it in ways that produce these eerie echoes. Alternatively, the echoes might be a sign of interactions with dark matter, which could distort the path of light as it moves through the galaxy. What makes these light echoes so fascinating is their potential to reveal hidden aspects of NGC 1300's structure. By studying the timing and intensity of the echoes, astronomers can map out the distribution of gas, dust, and other materials within the galaxy. This, in turn, helps us understand how the galaxy has evolved over billions of years and what forces are shaping it today. It's like using sound waves to map the ocean floor, except here, we're using light to explore the depths of space. As we ponder the origins of these galactic echoes, we're reminded of how much we still have to learn about the universe. Each echo is a whisper from the past, a clue that could help us unravel the secrets of NGC 1300. And with that, we'll move on to our final phenomenon, the phantom dark matter, where the invisible becomes the inexplicable. Stay with us as we uncover the last piece of this cosmic puzzle. Now we arrive at the final and perhaps most enigmatic phenomenon in NGC 1300, the phantom dark matter. Dark matter, as you may know, is the invisible substance that makes up a significant portion of the universe's mass. It doesn't emit, absorb, or reflect light, making it impossible to observe directly. Yet, its presence is felt through its gravitational effects on visible matter. In NGC 1300, however, dark matter seems to be playing by its own rules, behaving in ways that challenge our current understanding of the cosmos. One of the most puzzling aspects of this phantom dark matter is its irregular distribution. Unlike in other galaxies, where dark matter tends to form a smooth, halo-like structure around the visible components, in NGC 1300, it appears to clump and shift unpredictably. Some regions of the galaxy show an unusually high concentration of dark matter, while others seem almost devoid of it. This uneven distribution has left scientists scratching their heads as it contradicts the standard models of how dark matter should behave. What could be causing this strange behavior? One theory points to the galaxy's turbulent history. NGC 1300 may have experienced multiple collisions or interactions with other galaxies in the past, disrupting the normal distribution of dark matter. These cosmic encounters could have stirred up the dark matter, causing it to clump in some areas and disperse in others. Another possibility is that the dark matter in NGC 1300 interacts with itself in ways we don't yet understand. While dark matter is typically thought to be non-interactive except through gravity, some researchers speculate that it might have weak interactions with other dark matter particles, leading to these unusual patterns. The implications of this phantom dark matter are profound. If dark matter can behave so unpredictably, it could force us to rethink our understanding of the universe's structure and evolution. Current models of galaxy formation rely heavily on the assumption that dark matter is uniformly distributed. If that assumption is wrong, it could mean that our theories about how galaxies form and evolve need a major overhaul. Moreover, the behavior of dark matter in NGC 1300 could provide clues about its true nature, whether it's made up of particles we've yet to discover or something even more exotic. As we wrap up our exploration of NGC 1300's 50 strange phenomena, the phantom dark matter serves as a fitting reminder of how much we still have to learn about the universe. Each mystery we've uncovered, from the enigmatic spiral arms to the vanishing stars, has deepened our curiosity and expanded our understanding. And while we've come a long way, the cosmos continues to hold secrets that challenge and inspire us. Thank you for joining us on this journey through the wonders of NGC 1300. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more space mysteries. Until next time, keep looking up. And so we reach the end of our journey through the 50 strange phenomena of NGC 1300, a galaxy that continues to defy our understanding and spark our imagination. From the enigmatic spiral arms that twist in ways we can't yet explain, to the phantom dark matter that behaves unlike anything we've seen before, each mystery has revealed just how much we still have to learn about the cosmos. These phenomena aren't just quirks of a single galaxy, they're windows into the deeper workings of the universe itself, challenging our theories and pushing the boundaries of what we thought was possible. What makes NGC 1300 so fascinating is how it reminds us that the universe is far stranger and more complex than we often assume. Every discovery raises new questions, and every answer leads to even more mysteries. Whether it's the vanishing stars, the unexplained gamma-ray bursts, or the phantom galaxies that appear and disappear, each phenomenon invites us to think bigger, dig deeper, and stay curious. And that's the beauty of space exploration. It's a never-ending journey of wonder and discovery. Now, we'd love to hear from you. What do you think about these strange phenomena? Do you have a favorite mystery from NGC 1300? Or perhaps a theory about what might be causing them? Share your thoughts in the comments below. We're excited to hear your ideas and continue the conversation. And if you enjoyed this deep dive into the mysteries of space, don't forget to hit the like button, subscribe to our channel, and ring the notification bell so you never miss out on our next cosmic adventure. Until then, keep exploring, keep wondering, and keep looking up at the stars. The universe is waiting to reveal its secrets, and who knows, maybe the next big discovery will come from you. Thanks for watching.